Good day to you. Welcome to MV Tutors. My name is Figa and I am your tutor today. So we are doing the June 2021 Mathematics Paper 2. This is the memo. We are trying to explain it in a more digestible way. So without any further ado, let's get right into it. Cool. So it says Sam recorded the amount of data in megabytes that she had used on each of the first 15 days in April. The information is shown in the table below. So there we go. We got the megabytes there. Now it says calculate the mean, also on B, the standard deviation. So ladies and gentlemen, questions like this, you go straight to the calculator. Don't waste time trying to get formulas and solve it from first principle. Just use your calculator. So here we go. Am I going to put let me put it right there. Right over there. Okay, cool. So it says now the first data. So how you do this is you go to shift there. I've pressed shift. No, we don't need shift. First you go to mode. We need the stat mode, which is number 3. So I'll press 3. And then from here we have one variable. As you can see, it's a table of 1. So we'll press number 1. Okay. And then the first, we'll put in our data. The first one is 26. So we'll put 26 and then you put equals to 13. Equals to, the next one is 3, the next one is 18, the next one is 12, the next one is 34, the next one is 24, the next one is 58, the next one is 16, there we go, next one is 10, almost there. Next one is 15, and then 69, and then we got 20, then we got 17, and then we got 40. Great, there's 15 of them, first 15 days. Cool, now that you filled it in, you can press AC. Okay, it's just clearing the data, but the data is still there in the, what do you call this, a calculator. So to get the mean, you go shift. Okay, so shift all the things that what color is this? Brown. You need to press shift to get access to the brown things, like these ones, and then alpha for the red ones. But since we are looking for this stat mode here and it's brown, so we press shift, and then stat is number 1, so we press 1. What are we interested here? Okay, we're interested in the variable, so that's number 4. Okay, so we'll press 4. Now to get the mean, that's the mean there, which is number 2, so we'll press 2. And then we'll press equals to, and it tells us the mean is 25. Let's go ahead and write that down. Our mean is 25. Now for standard deviation, let's bring back that calculator. Standard deviation, you clear that once again, and then we go shift and stat. Okay, back to variables, shows number 4, and for standard deviation, it's this one, which is number 3. That's the symbol for standard deviation. So we'll press 3, and then we press equal, 17.65. Okay, so there we go. We have 17.65. That's it. That's how you do that. And then it says determine the number of days on which the amount of data used was greater than 1 standard deviation above the mean. The first difference of a question is understanding what it wants, understanding the English behind it. Because if you understand what the question wants, you are most likely to answer correctly. But if you don't understand what the question wants, you're most likely not to answer correctly. So over here, what does this question want? So, we are told it's 1 standard deviation above the mean. So here we are dealing with a standard deviation and a mean. So what does that mean? 1 standard deviation above, that means we add them up. Okay, so we're going to have the standard deviation and we're going to add it to the mean. Okay, standard deviation is 17.65 plus the mean is 25. Okay, let's just put that quickly in our calculator. Now you are still on stat mode as it shows there on your calculator. So to go back, you press mode and then you press 1. There we go, we're back. Now we're back to proper math. Okay, so we can do our math gymnastics. Let's just put this aside. So now we want 17.65 plus 25, and that's going to give us 42.65. Thank you so much. So that's 42.65. Now, what do we do with this? What do we do with this? It says determine the number of days. So when it says number of days, we are actually looking for number of days where the data is 42.65 or above it. So, or let me just say the number of days where it's above 42.65. So if we look here, this is less than 42, less. This one is more, so we got 1 there. Less, more than 42. So we got 2 there. What? Less. So your final answer then is 2 days. That's it. Cool. Now the next question says calculate the maximum total amount of data that Sam must use for the remainder of the month if she wishes for the overall mean of April to be 80% of the mean for the first 15 days. Ladies and gentlemen, like I said, the English is the one that you need to understand. So let's put this question into context. What is it actually saying? So what this question is saying is that, all right, so maximum amount, a remainder of the month if she wishes for overall mean to be 80% of the mean of the first. So let's do this. The mean is 25. Okay, and then they are saying they want, if she wishes for the mean of April to be 80% of the mean for the first 15 days. Okay, let me put it like so. The first 15 days, this is 15 days, right? So for the first 15 days, you're gonna have, let's just put a timeline like that. You have a mean of 25. Okay, this is the first 15 days. Now to complete the month has 30 days, right? The month has 30 days. So this is another 15 days, which makes a complete month. So they are saying, and then let's make this mean, so the mean of first 15 days is that. This mean is the one that we have to calculate it. Okay, so let's just call it mean And then what they are saying about this 80% is that the overall mean, when I add these two means, must equal 20% of 25. Okay, so let's put this in a proper equation now. So they are saying 25 plus the mean that we are looking for, the average of them, if you add them, average is divided by 2. Same as use for the remainder of them if she wishes the overall mean. So we're still dealing with the mean, the overall mean. So to get the mean between these two, the mean between these two must be equals to 20%. So it's 20. That's 20% of 25. Okay, so let's do this then. Let's just put the calculator. This one will remain the same. Let's just get this one first. Let's get a calculator. So we are saying 20%, it's 20 divided by 100 times 25, which is 5. Which is 5. Why did I say 20%? I'm making mistakes here. 20% is the one we're supposed to subtract. It's actually supposed to be 80%. So let's put an 8 here. It's 80%. Oh, that's 20. Answer is 20. So like I said, it's not 20%. Let's make that correction. It's 80%. As you can see over there. Ladies and gentlemen, I'm not going to record over this because I want you to learn that if you make a mistake, you should be able to just go back and correct your mistake. We're not trying to be perfect here, but what we are trying is to learn from our mistakes and correct them as we go. Okay, so the answer is 20 there. This side we have 25 plus the mean divided by 2 to make it an overall mean. Now we just have to do mathematical gymnastics to solve for the mean. First thing we're going to do is get rid of the 2 by multiplying both sides by 2. And when we do that, we're going to have 25 plus the mean we are looking for. And that's going to be equals to 20 times 2 is 40. And then the mean finally is going to be 40 minus 25. And what is 40 minus 25? If you said 15, then you are correct. Okay, so the mean is 15. Okay, so what is this 15? What is it? Let's try to understand the question. Calculate the maximum total amount of data. Oh, they want the total, the maximum total amount of data that Sam must use for the remainder of the month. So they wanted for the remainder of the month. This one is per day. Let me just put it there and say per day. Okay, and if you look here, how many days do we have? We have 15 days. So what we're gonna do is that to get the total amount for the month, what we have to do then is that we have to say 15 days, which is the remainder of days, times the 15 megabytes. Okay, so these are megabytes per day. Times 15 days, and then 15 times 15. Let's just bring in the calculator. 15 times 15 is equals to 225. So the total amount is 225 megabytes for the rest of the 15 days, which is what the question is looking for over here. All right, well, I hope it makes sense, but in the event that it doesn't, do book a session with me. I'd love to explain these things to you, how they work. So book a tutorial session with me. You can visit my website, which is www.mvtutors.co.za. Book a free consultation there, or you can WhatsApp me on 076-312-1107. Okay, now let's continue with the rest of the question. It says the wind speed in kilometers and temperature in degrees Celsius for a certain town were recorded at 4 p.m. for a period of 10 days. The information is shown in the table below. Let's put it this way. Determine the equation of the least squares regression line for the data. So this again, we need a calculator. You cannot do it with your head. Well, you can technically, but it will take you a very long time. So let's get a calculator. Okay, so there we go. I'll put it right there. Okay, so here we go again mode. All right, and we go stat. Still dealing with stats. Now we have two variables now. Okay, two variables. Here we had one variable there. Now here we have two variables. So we'll press 2 here. It's a plus bx. Okay, and then so we'll press 2. Okay, there we go. Now we need to put in the values for x and y. So x, we've already been given here, is the wind speed, these values, and then y will be these values. Let's start with the x values. So the first one is 2, the next one is 6 equals, next one is 15 equals 20 equals 25 equals 17 equals 11, 24 equals 13, and then the last one is 22 equals, so 10 data sets. There we go. Let's go to the fill in the y values. The first one is 28. So we go equals, and then 26 equals, and then 22 equals, and then 16 equals, hold up, 22 is twice, right? So let me go back. 26, 22. So I should put a 22 right here. And then 16. 16 is the fifth one, right? 1, 2, 3, 4, 5. It's the fifth one. That's cool. So the next one is 20 equals, and then 24 equals, and then 19 equals, and then 26 equals, and then the last one is 19 equals. So 10 for 10. Okay, we're done with that data. And then we clear it. Now we're looking for the regression line equation. So we have to go shift stat. Okay, now we're looking for regression line. So you see number 5, it says regression. That rig, it's number 5. So now it comes with A and B. Okay, so for A, press 1 and then press equals 29.35. Let's just write that down. 29.35 for A. A is equals to 29.35. Okay, and then we're gonna need B. So let's clear this. Shift, stat, regression line number 5, and then we're gonna need the value of B minus 0.46. Okay, so B is equals to minus 0.46. Now check this out. They wanted us to solve the equation. Actually, that's what they're interested on. So for the equation is given by y is equals to a plus b x. This is the equation of the regression line. So a is 29.35, b is minus 0.4, so it's minus 0.46 x. This, ladies and gentlemen, is our answer. That's the equation for the regression. All right, and then it says predicts the temperature at 4 p.m. Well, only these values are at 4 p.m. if on a certain day the wind speed of this town was 9 kilometers per hour. So wind speed is x, right? You can see it there. And then y is the temperature. So they want us to solve the temperature, meaning we're gonna use the very same equation. So now this is 1.2.2. We'll use the same equation above for y. So it's gonna be y is equals to 29.35 minus 0.46. Where there's an x, we'll substitute that 9. Let's get the calculator. Right there. Let's bring it this side. This time we need to go back to our math stat. So we go mode, comp, we're back to math. So now we can say 29.35 minus 0.46 times 9. So we'll put that 9 in the brackets. 25.21. 25.21 is our final answer. 25.21. Now, what is this? What is what? Degrees Celsius. Okay, so it's in degrees Celsius. That's our final answer. Cool, let's move on. Well, let's go to the last question now, which is 1.2.3. 1.2.3. Okay, so interpret the value of B in the context of the data. So that's the same B as that one over there. If you look at that line, the equation, B is actually B is the gradient, right? B is the gradient and it's a negative 1. So if it's a negative 1, it means that, well, if you were to draw the line, it would be like that. Okay, so what does this mean? If I'm driving my car on top of here, okay, there's my car over there. All right, and then I come here, it will start moving down as it approaches. Remember, it always approaches from left going right. It will decrease. So then we can conclude and say that interpreting B, the wind speed is going to, it's expected the wind speed is going to decrease. So B tells us that wind speed will decrease, or wind speed decreases due to having a negative gradient. Negative gradient. Well, that's all for 1 mark. That's all you had to say. Well, I hope you understood, but in the event that you didn't, you know what to do. Just contact me, visit my website and book a free consultation, www.mvtutors.co.za, or WhatsApp me on 076 312 1107, and I'll be waiting to help you. Okay. Enjoy the rest of your day. Goodbye now. Well, hello there. Welcome to MV Tutors. My name is Figa, and we are doing the 2021 June exam paper for mathematics, paper 2. Okay, we are now in question number 2. Well, let's get right into it. It says the number of days that grade 8 learners were absent at a certain high school during a year was recorded. This information is presented in the table below. Okay, there we go. Right, now we have number of learners here, and then we have number of days absent. Okay, so they give us a range between 0 and 5 until 25 and 30. Okay, now they say write down the model class for the data. Now, if you know what the mode is, when they talk about the mode, they talk about the one that is the most. Okay, so we can see here that actually 98 is the most. Okay, so the model class for the data. So the model class is then 10, this one, where x is between 10 and less than 15 days. Okay, how many learners were absent from school for less than 15 days? How many learners were absent from school for less than 15 days? So less than 15 days is as you can see, this is less than 15 days over here. So what we really have to do is add these up. So we're going to say 34 plus 45 plus 98. Is that going to give us, get a calculator real quick. There we go. Put it this side. And we'll say 34 plus 45 plus 98. And then we get 177. Thank you so much. So 177 is our final answer. It's 177 what? 177 learners. Just like that. Cool. Now, how many grade 8 learners are at the school? Wow. Okay, so for this one, we have to add up everything. All of these learners. Okay, so I will do what we call a cumulative frequency. So let me just do it here. Let's say cumulative. Cumulative, like that. Okay, let me just complete some few lines to distinguish. So that will be that. That'll be that. That one goes with that. That one goes with that. That one goes with that. Wow, it's really untidy, but we'll get back to it. So we start off with 34. 34 plus 45. My goodness, I need a calculator. I'm just gonna grab the same calculator, the one that I have digital. It's just that I think it'll be quicker this way. 34 plus 45, that gives me 79, and then 79 plus 98, that gives me 177. That, and then 177 plus 43, that gives me 220. 220 plus 7 gives me 227. 27, and then 227 plus 3, that gives me 230. So how many learners are there? Grade 8, there are 230. Okay, and then it says draw the cumulative frequency graph, Ogive, to represent the data above on the grid provided. Well, I haven't been provided with any grid, so I'm gonna make up my own. Fortunately, it's as easy as a touch of a button. There, we're done with it now. So, okay, now we have this. Now I want you to know something. Okay, I want you to know that the cumulative, this one goes on the y-axis. Always gonna be on the y-axis. Okay, y-axis. And then we're gonna put this one, number of days absent, on the x-axis. All right, cool. Let me just leave it this side. Let's make some space this side, and then so I think I'm gonna let's start with the y-axis. It seems to be a bit longer. So 230, we have to start from 0 to 230, so we can do it. Let's use periods of 30. How about that? So we'll have 0 here, and then we'll have 30, 60, 90, 120, 150. 150 plus 30 is 180. 180 plus 30 is 210. And then finally we'll have 240. Good. Now let's see. These ones there, we can do them. Yeah, we can do them exactly like this in periods of 5. So 0 is there, so we'll have 5 there. 10, 15, 20, 25, goes up to 30. Fantastic. Okay, and then we can draw our number line, our Cartesian plane rather. Okay, so there we go. So let's label this. This is number of days. Okay, this is number of days. That's number of days absent, to be exact. And then this one over here on the y-axis, then we have our cumulative frequency. Cumulative frequency. Like that. Okay, so now we need to mark the points. In marking the points, we're going to use these values this side. together with the cumulative value. So the first one that we have is 5 and 34. So 5 on the x, 34 on the y. So 34. So this is 30, 40, 50, 60. So 34 is somewhere here. Well, not really, but yeah, somewhere there. And then 10 and 79. Remember, we're doing the cumulative one. 10 and 79. So 79 would be somewhere there. Cool. The next one is 15 and 177. 15, 177. If that's 180, 177 is somewhere there. Okay, next one is 20 and 220. That's 210, 220 somewhere there. The next one is 25 and 227, which is somewhere there. And then the last one is 30 and 230. 230 then is somewhere there. Okay. Now we need to join these lines. I know that most people like drawing curves, but you know, I prefer straight lines. So straight line from there to there to there, straight line from there to there. I mean, it's still gonna make a curve. It's just a curve with straight lines. I find it to be more accurate. Okay, so there we go. We're done with our cumulative frequency graph. Now they say use the cumulative frequency graph to determine the median number of days the grade 8 learners were absent. Okay, so we are looking here for the median. Okay, and for us to solve the median, there is actually a formula that we can use. So let's have there. Let's just say this is 2.5. The median formula, it doesn't give you the median, it gives you the median position. Okay, so the median position formula is half, and then that's the total cumulative number plus 1. Okay, so that's going to be equals to a half. Okay, open brackets, it's 230. That's the cumulative number plus 1. All right, we can use the digital what's this, calculator. It's the same calculator, as you can see, very same. The only difference is that this one has got a screen over there, but really it's the same thing. Okay, so let's move it over here. All right, so we're gonna put a half. Let's put it exactly as it is. So 1, and then we'll put a 2 downstairs. Go to the side, open a bracket, put 230 plus 1, close the bracket, and what's that equal to? Let's have it in decimal. 115.5. Let's make it 116. Cool, 116. Right. So what does this mean? It means we come here, we look for the position, the 1/16th position on the cumulative part. So we look for 116. So that's 90. It's gonna be 100, 110. So 116 somewhere here. And then we'll draw a line. Bam. And then we'll come down from there. Whatever answer we come down to. Great. So that's really between 10 and 15. Okay, so the median is between 10 and 15. That's what we can say. If you draw a curved one the range is still going to be the same. We might not get the same answer because I'm getting, for me there, that value there, it looks more like a 10, 11, 12, 13, 14. It looks more like a 12. But the correct answer is to say 10. It's between 10 and 15. That's it. Well, in the event you didn't understand anything, I would love to be your tutor. So do contact me, visit my website, www.mvtutors.co.za, or WhatsApp me on 076 312 1107, and I'll be glad to assist you.
Hello everyone and welcome to MV Tutors. I'm Solo and I'll be looking at question 3 with you from the supplementary exam written in June this year, 2021. Alright, so let us get to it. So it says in the diagram, S, we can see S there. It's actually on the y-axis. It has the coordinates 0 and minus 16. L and Q with coordinates 4 minus 8 are the vertices of triangle SLQ. Okay, you can see it's a right angle triangle having LQ perpendicular to SQ. Alright, SL and SQ are produced to points R and M respectively, such that RM is parallel to LQ. SM produced cuts the x-axis at N. QM is equal to MN. Okay, so they have the same length. T and P are the y-intercepts of RM and LQ respectively. Okay, so first question, calculate the coordinates of M. Alright, so if you have a look here at M, this is where M is situated. Okay, M is actually halfway of Q and N. So we'll be using our midpoint formula to actually calculate the coordinates of M. Okay, so let us do that. 3.1. Okay, so the midpoint of M, that will be equal to the x-coordinate of Q plus the x-coordinate of N, okay, all over 2, and we have the y-coordinate of Q plus the y-coordinate of N all over 2. Okay, so we already have Q, its x-coordinate is 4, and N, the x-coordinate is 8. The y-coordinate of Q is negative 8. Then we have 0 for N. Alrighty. So finally, we have 4 plus 8 is 12. Divided by 2 is 6. And then we have negative 4 this side. And does our answer actually make sense? If you look at Q, we can see that the y value is negative 8. And if it's somewhere negative 4 actually makes sense. We are expecting it to be negative 4 because it's halfway between 8 and 0. And then with the x-coordinate, we have 8 for N and 4 for Q. So in between 8 and 4 is 6. So yeah, I'm happy with the answer. We can then go to 3.2. Calculate the gradient of NS. Okay, so where is NS? This is S over here, and that is N. Okay, so we can just pick any 2 points on that line, NS. Okay, and we know the gradient is literally just, the change in Y over the change in X. Okay, so the change in Y, I will say the y-coordinate of S minus the y-coordinate of N all over the x-coordinate of S minus the x-coordinate of N. Okay, and then S, the y-coordinate is negative 16. The y-coordinate of N is 0. the x coordinate is 0 for S, and the x coordinate is 8. Firstly, what gradient are we expecting, a positive or a negative? For the fact that from left to right it's going up, we're going to expect a positive gradient. Okay, so if you have a negative gradient calculated, you know that it is wrong. So we have negative 16 over negative 8, and our gradient is then 2. Okay, great. And now they say question 3.3, show that the equation of the line LQ is that. Okay, so this is where LQ is. Okay, so if you want to write an equation, I normally say, you need a gradient first of all, and you need a point. If you have those, guys, then you're good to go. All right, so LQ is actually perpendicular to NS, okay? So if the gradient was 2 for NS, you know that the gradient, I'll say, yeah, LQ times the gradient of NS, that should give you negative 1. So if the gradient of NS was 2, then it means the gradient of LQ is negative a half. So we have that. We have a gradient. We're sorted. Now we need a point, okay? Currently, we only have the point Q. So you can't use any other point unless if you worked it out somewhere. But Q is what we're going with, okay? And Q is 4 and negative 8. So if we want the equation, we're going to, in this equation, y is equal to mx plus c. Y, when we substitute that point, is actually going to be negative 8. Your gradient is negative a half. Okay, the x value is 4, and we're just going to calculate what the c value is. And it makes sense. I mean, the gradient has to be negative because LQ is going down from left to right. So the gradient should be negative. All right, so when we calculate c will be equal to negative 8. And if I take negative half times 4, I get negative 2. Take it to the other side, it'll be positive. So c is actually negative 6. Okay, which is the, what do you call this? It is the Y-intercept. Okay, so that's where P is actually. Alrighty, so finally our equation will be y is equal to negative half x negative 6, and that is exactly what they asked us to show. Okay, so we are good with 3.3, and now we go to 3.4. What do they want? So they're saying determine the equation of a circle having center at the origin, at O or 0 if you may, and also passing through S. Okay, so basically, if I were to draw in this equation, this circle, it's something like that. Okay, it's quite a big circle. It won't even fit on the graph, but it's something like that. Okay, so the center is at the origin. Okay, and since the center is at the origin, it's your basic equation where you would say x squared plus y squared is equal to r squared. And by S being when it passes through S, I would then assume that OS is the radius. Okay, and we already know that that length is 16. Okay, we're gonna take the positive, so it's 16. So yeah, we can then say x squared plus y squared is equal to 16 squared. Okay, so you can either leave it like this, or you can actually work out what 16 squared is. I do not know. All right, so 16 squared, that's 256. Okay, so you can say x squared plus y squared is equal to 256, and that is your equation. Alrighty, so question 3.5. Alrighty, so it says calculate the coordinates of t. Okay, so where is t? T is actually the y-intercept of Rm. Remember, you know what m is, okay? And actually, for you to actually get the y-intercept, you need to get the equation of that line. We have the coordinates of m. We'll have a look now what it is. And we have the gradient. Remember, LQ is parallel to Rm, okay? So the gradient of LQ is actually equal to the gradient of Rm. Parallel lines have the same gradient. Perpendicular lines, if you multiply their gradients, it should give you -1. Okay, so the gradient of LQ was -1/2. So the gradient of Rm will also be -1/2. Okay, so we have our gradient. Now we need a point. And we already have a point M. I forgot the values. We did it at the very beginning. So it's 6 and -4. Okay, so 6 and -4. So we can just get the equation, all right? And in so doing, you'll actually get C, which is T, the y-intercept of the equation Rm, or the line Rm. Okay, so again, y is equal to mx plus c. Y is -4. The gradient is -1/2. X is 6. And now we're solving for c, which is t. Okay, so c is equal to -4. And then -1/2 times 6 is -3. If you take it to the other side, +3. So then our gradient, our intercept is -1. That is t, actually. So t, since they asked us for the coordinates, it's going to be 0 and -1. Okay, guys, so far, things are going pretty well. You should be knowing these things. Okay, let me just shift this a bit so that I can move up. Okay, let's just make sure we see all the questions as well as the information. Alrighty. So now we get to 3.6. Okay, and it says determine LS, length LS over RS. So where is LS? Okay, let me just see it over there. Okay, so LS, okay, there it is. So the length LS, all right, over RS. Oh, okay, so it's that one there. And it is 3 marks. Okay, so I would, if I think about it, use the distance formula to get LS and the distance formula to get RS. Okay, so RS, I don't have the coordinates of R, okay, and I only have the coordinates of S. What else do I know? Yeah, let me try to redraw it so that I see. Yeah, we don't have L, but that should be fine. Okay, let's see how we can do it. Okay, so I just wanted to take time out to draw it in a way that when you see it, you realize that you actually need the proportionality theorem to calculate this. So they're looking for LS over RS, okay? LS over RS. So as you can see, oh, I forgot to put L there. So LS, did I draw it right? Yes, SLR. So LS or SL, like we see here, over RS, okay, it will be equal to, according to the proportionality theorem, SQ, okay, SQ over SM. Okay, cool. So now we need to get the lengths of SQ and the lengths of SM. Okay, so yeah, we're gonna use the distance formula here. So for SQ, okay, so I'm gonna say the x coordinate of S minus the x coordinate of Q, all of that is squared, plus the y coordinate of S minus the y coordinate of Q squared. Okay, and that will be over, okay, but remember there's also that square root. Ooh, okay, no, never mind. Okay, so square root, I'll just put it by hand. And then we have the x coordinate of R minus the x coordinate of S plus the y coordinate of R minus the y coordinate of S. And that as well has to be under the square root. Okay, so let us put in the values. The x coordinate of S is 0. For Q, it is 4. Okay. The y coordinate is minus 16. For Q, minus 8. So minus and a minus will become a plus. Hence, I have a plus there. Not forgetting our square root. Okay. And then for R, we have... why did I say R? Sorry, guys. Yo, I meant S and M. Okay, so I'm just going to use M here, not R. My goodness. Okay, but yeah, the x coordinate of M. That is 6. And the one for S, that is 0. Okay. Ooh, at least I saw that error. And the y coordinate of M is minus 4. And then for S, it is minus 16. So it'll be plus 16 squared. And all of that is under the square root. Okay, so minus 4 squared, that's 16. And then minus 16 plus 8, that is negative 8. 8 squared is 64. Okay, and then we have 6 squared, that's 36. And then we have minus 4 plus 16, that's actually 12. 12 squared, that's 144. Okay, so 16 plus 64, that is 80. I think at this point, you just plug everything in the calculator to save time. I'm wasting time here. Okay, 144 plus 36, that's actually 180. Then we can plug that in the calculator and see what answer we actually get. Okay, so we have root 80 over root 180, and that is equal to, okay, 0.66666. Okay, if you know that value, if you've seen it quite a couple of times, you would know that it's actually 2 over 3. If it was 1 over 3, it would be 0.33333. But if it's 2 over 3, it's 0.66666 until you eventually get to 7. I mean 0.67, that is. But yeah, and if you wanted to expand this third, you would actually get to 2 over 3. But we're not going to do that. Okay, lastly, question 3.7. Calculate the area of PTMQ. Okay, so this is P, that's T, M, and that's Q. So we're actually looking at a, what do you call this? A trapezoid. We're looking at a trapezoid, okay? So I'm just going to sketch it quickly and we'll answer the question, which is the area. Alrighty, so yeah, we have our trapezoid there, PTMQ, and we need to get the area. Okay, so I'm going to just share with you the area of a trapezoid. Don't mind the mic, I'm just trying to eliminate external noise. But the area of a trapezoid, okay, so it will be half, and then we're going to take the two parallel sides, okay, so which is PQ plus TM. Then we're going to multiply it by the, should I say perpendicular bottom width, if I could say so. That's QM. Okay, and as you can see now, we are really going to have to, we're going to have to calculate the lengths of PQ, TM, and QM. All right. Okay. So the area is equal to that. So area of PQ, the length of PQ. I'm not going to write the full length equation again. I'm just going to substitute values in. Okay, so let's start with PQ. So the x value for P is 0. For Q, it's 4. Okay, and then, that's 16. And then we have the y value for P, which is minus 6, and Q, which is minus 8. So minus minus will become a plus, and that's squared. All of that is, rooted. Minus 6 plus 8 is minus 2, so that's 2 squared is 4. Okay. And then our answer is 20, root 20. So that is PQ. And now we get to TM. Okay, so TM, let's just do that. So the x value for T is 0, okay, and the x value for M is 6, and 6 squared is 36. We're just writing it. All right, the y value for T is minus 1, and for M is minus 4. So minus 1 minus minus 4, that is 3. Okay, 3 squared is 9. Okay, 36 plus 9, that is 45. Square root of 45. So that's TM. And then QM is the last one. Okay, so QM. Okay, so QM is, right, so the x value for Q is 4. The x value for M is 6. So 4 minus 6, that's going to be minus 2. And minus 2 squared, that's actually 4. And then the y value for Q is minus 8. Minus 8 minus minus 4, that's minus 8 plus 4, that's actually minus 4. And minus 4 squared is 16. Okay, and then we also have root 20 there. So coming back to our equation of the area. Nope, not everything is selected. What's happening? Okay, it's fine. Copy. Okay, so we have our area there. I could have just written it down again. It's 1 over 2. So PQ, I think it was root 20. Yes, so we have half root 20. TM is root 45. And QM is root 20. Okay, and then we're just going to plug everything in the calculator. And then we are done with this question. Okay, so we have a half times root 20 plus root 45 and multiplied by root 20. Okay, oh wow, 25. It's a nice rounded number. Okay, so 25 units squared. They didn't give us the units, so you're just gonna write the word unit, and squared because it's an area. Okay, and we are done. Okay, this was not a bad paper, but yeah, I'm glad we are done. And I hope that you learned something. Okay, enjoy the rest of your day depending on when you're watching, and yeah, tune in for more questions from paper 2.
Hello everyone and welcome to MV Tutors. I'm Tsolo and I'll be looking at question 4 with you guys
from the supplementary that was written in June this year. All right, so we have a circle there. Okay, so in the diagram, P is the center of the circle. V and W are the endpoints of a diameter. The circle intersects the y-axis at B and C. BCVW is a cyclic quadrilateral. Alright, so CV is produced to intersect the x-axis at T, and then OTC is equal to alpha. Alright, what do they require of us? Okay, so the radius of the circle is root 10. Okay, so if I were to just mark it over here, so if I have root 10, here's my radius. Look at me writing root 20. Root 10, it means there I have root 10. It means the whole diameter. Okay, the entire diameter then will be equal to 2 root 10. Okay, so if the radius, okay, so the radius of the circle is root 10, calculate the value of K if point V is to the right of point P. So there is V. We just need to get the X value, which is K. Okay, but to the left of P we have W. Alrighty, so the equation of our circle, remember you have x minus x1 and then we square it. Then you have y minus y1 squared, and that will be equal to r squared only if your circle is not at the origin. The origin being point 0 or no, O. O for origin. So we already have our x value. Okay, our x value is negative 3. So negative times negative, I'll have a positive. Alright, and then I have my y value there, and I have 4. Okay, that's already given. And my radius has been given as well. It's root 10, but I'm squaring it. And now I have a point that is V. Okay, and I'm going to substitute this point in this equation so that I can determine what the value of K is. So wherever I have X, I'm going to substitute it with K. So I have K plus 3 squared. And wherever I have Y, I will substitute it with 1. So 1 minus 4. And then that will simply be 10. So now I have K squared plus 6X plus 9. 1 minus 4 is minus 3, so minus 3 squared is 9. And I'm going to take the 10 this side. So that's just equal to 0. Okay, then I have remaining K squared plus 6X. 18 minus 10, that will be 8. Okay, and if I factorize, you can use the quadratic formula if this kind of factorizing is a little bit tricky for you. But basically what I do, I look at the factors of 8, okay, and I see if I have to add or subtract them, will I get this number in between? So the factors of 8, I have 1 times 8. If I add 1 and 8, I get 9. If I subtract, I'll get 7. Okay, so that doesn't work. But if I use 2 and 4, if I add them, I get 6. So that is what I will go with. Yeah. And then finally, I have that K is negative 2 or K is equal to negative 4. Now they've asked us to determine K to the right of P, right? Yes. So the only solution I can really have is negative 2. K cannot be negative 4. But W, on the other hand, W's coordinates, you can see there, I have negative 4. And I don't know what Y value I have there. But K, we know that it's V, which is negative 2 and 1. Okay, and yeah, 5 marks. A nice 5 marks. Okay, 4.2. The equation of the circle is given as that. Okay, so calculate the length of BC. If you look at BC, it's on the y-axis, right? Those are the y-intercepts. And I know that if I'm calculating the y-intercept, then x has to be equal to 0. So I'm just going to write down that equation. X squared plus 6x plus y squared minus 8y plus 15 is equal to 0. And then I'm going to substitute x is equal to 0, so those terms cancel out. Then I'm left with y squared minus 8y plus 15. Again, I'm going to factorize. So, the factors of 15, I have 1 and 15. If I add them, I get 16. If I subtract, I get 14. Okay, so that's not going to work. But I also have 3 and 5, and I know that 3 and 5 gives me 8. Okay, and if I say negative 3 plus negative 5, I'll get negative 8. If I say negative 3 times negative 5, I'm going to get positive 15. So we are sorted. All right, so y is equal to 3 or y is equal to 5. Okay, so basically C will be the one with 3. Okay, and B, since it's higher up, it'll be the one with 5. And now they asked for the length of BC. Okay, so let's not forget what we're doing here. Okay, so the length of BC is just the difference between the 3 and 5. 3 and 5, I'm already thinking ahead, and that is 2. So the length of BC is 2. Okay, now we get to 4.3. And they're saying if k is equal to negative 2, which we already know it is, we worked it out. But just in case you got it wrong somewhere, then yeah, there's the answer. So v is negative 2 and 1. Okay, those are the coordinates of v. Now we need to know the size of alpha. Okay, so if we're going to get the size of alpha, let me just use a different colored pen. So alpha is bound by that. Okay, that's where alpha is. And you would know that if you have a line passing the x-axis, okay, there's an angle, you would be reminded that actually tan alpha is equal to the gradient of that line. So we need to get the gradient of the line TVC. Okay, so I'm just going to say, because I don't have the coordinates of T, I'm just going to say VC. Okay, so what is the gradient of VC? The y value for C, why do I keep doing that? The y value for C, let me just put in the coordinates. So I have 0, 3 and I have 0, 5. So the y value for C is 3 and the y value for V is 1. The x value for C is 0, x value for V is negative 2. So negative will give me positive. So basically I have 2 over 2, which is 1. Okay, but remember we're looking for alpha. So alpha is 10 to the power minus 1. And because 1, okay, if you know your special angles, you would know that the arctan of 1, it's actually 45 degrees. Okay, so that is alpha. And now 4.3.2. We are looking, so if you're looking at triangle VWB, so there's VWB, so it's that triangle there. We want to know what W is. Okay, how are we going to do that? Okay. Remember that when you have a chord that is a diameter, the angle it subtends will be 90 degrees. So we know for one that B is 90 degrees. So if I were to redraw this, okay, That's V, and V is negative 2 and 1. B is 0 and 5. And then I have W there. So I'm looking for this angle here, W. Okay. I can determine what the length of VB is. And I can also determine, oh, I actually have the length of VW. I've written it there. It's 2 root 10. So for me to get W, I would have to say sine W is equal to VB over VW. Okay, so I just need to get the length of VB. I know this looks like a lot of work for 2 marks actually. It really does. But yeah, the length of VB, okay, I'm just going to take the x values. So x value of B is 0. 0 minus 2, that's 2. 2 squared, that is 4. And then, so I'm using the distance formula. Okay, I'm not going to write it down. You have it in your formula sheet. I'm just going to shoot. Okay, then we have the y values. The y value for B is 5. 5 minus 1 is actually 4. 4 squared, that's actually 16. And remember, you have a square root there. So I have a square root of 20. Okay, getting back to W. W is actually arc sine. And then VB is what I just determined, which is root 20. And then VW, that is 2 root 10. So we can then put it in the calculator and determine what it is. Okay, so I have arc sine root 20 over 2 root 10. And that answer there will be 45. Oh, it's also 45 degrees. So I guess I took the longer route. Some way, somehow, you could have gotten it. I'm trying to see, because we have a cyclic quad. And I'm thinking external angle. Remember, the external angle in a cyclic quad is equal to the internal opposite. So yeah. No, I'm not seeing it. I don't know. Whoever's seeing a simpler way of calculating it, please comment below. I would have to, because I've made so many sketches here. And that would be, yeah, I need to erase what I drew here, but I can see something. if you have your cyclic quad here, and you have an external angle, surely something can happen. So that would be 135, right? Because you have 45. No, I'm lying. If this is 45, the entire thing has to be 135. So if you could get an external angle and work it out, maybe something could happen. Maybe, I don't know, but I'm just gonna leave it here. We have solved it. We are done with 4.3.2, and let us move on. Let's not waste any more time. So 4.4, a new circle is obtained. Okay, let me just take it up. So a new circle is obtained when the given circle is reflected about the line y is equal to 1. Okay, so I'm just gonna put that line there, y is equal to 1. Okay, so it's somewhere here. Okay, something like that. That is the line y is equal to 1. And then we need to reflect this circle about that line. Okay, so your circle is gonna start something like that. Then it also crosses the y-axis at 2 places. I tried, guys. Okay, so it's also gonna cross it somewhere here. And then straight down, you're gonna have your center somewhere. Please bear with me. Okay, so that is the new circle. And now they're saying 4.4.1, determine the coordinates of Q, the center of the new circle. So Q, there it is. Okay, so we have, I'm looking at the y values now. Ne? The x value will remain the same. The x value will be -3. But we need to get the y value, because that is what has changed. Remember, we reflected about y is equal to 1. We didn't reflect about x, so x will remain the same, but the y value will change. So previously we had 4, ne? And this line here is y is equal to 1. So for me to get from 4 to 1, I would have shifted 3 units down. Yeah, so 1, 2, 3, and then I'm at negative 1. So now, from here as well, I need to shift 3 units. So 1, 2, 3. Okay, so if here if I'm at 1, and I need to go 3 units down, do you agree that 1 minus 3 is actually minus 2? Okay, because you're at 1, then I need to get to 0, then minus 1, minus 2. Okay, I hope it makes sense, but for the visual learners, that's how you would do it. Okay, if there's an equation there that you know of, well, you're more than welcome to use it, but I know visually how to see what the answer is. All right, and then 4.4.2, determine the equation of the new circle. Okay, guys, that won't be bad because we already have the center. So it's x minus 3, which is x plus 3. And then we have y minus 2, which is plus 2 squared. And all of that, remember the circle just went down. Okay, it was not even went down, it was reflected about the line y is equal to 1. So the size did not change. It did not enlarge, it did not reduce in size, it's still the same. Therefore, the radius is still root 10. Okay, and we have written it in the form that they want, so we are good. Sorry about that. And then 4.4.3. Okay, if I just shift that up a bit. So, determine the equations of the lines drawn parallel to the y-axis and passing through the points of intersection. So basically, the points of intersection are here. Let me just edit that. It's such a hassle having to edit a PDF. It doesn't want you to just change colors in the middle of it. You need to now start from scratch. Okay, so do you see they intersect at V? And if you just take that up, they would intersect at W. And remember at the beginning, I determined that W is minus 4 and minus 2. So your answer therefore would be x is equal to minus 2 and x is equal to minus 4. That's 2 marks, ne? But for those of you who are wondering, how did I get to those values? What if you wanted to calculate it? So let's say you take your equation, okay? So you have x plus 3. You can take either this equation or the equation for the center of P. I'm just going to say equal to 10 because root 10 squared is 10. But now I have a y value of 1, so I can substitute it there already. And I'm just going to expand here. So I have x squared plus 6x plus 9. And then I have 1 plus 2, which is 3. And 3 squared again, that's 9. And I'm going to take 10 the other side. It's quite similar to the one we did previously, né? When we were calculating for k. So then I have x squared plus 6x and 18 minus 10, that's actually 8. Okay, and then I can then factorize. So I have x and I have 2 and 4. It's actually it's the same. Okay, and therefore you can see I have x is equal to minus 2, and so I'm saying and because we have two equations that are parallel to the y-axis. Okay, so parallel meaning they go down like that, and that equation is x is equal to minus 4, and parallel x is equal to minus 2. So they're all parallel. And that is it. We are done with question 4. I hope you understood. I hope you learned something. Please do comment below if you have questions. But yeah, that's it. Enjoy the rest of your day.
or evening.
Well, good day to you and welcome to MV Tutors. My name is Figa and we are doing question 5 now of the June 2021 Mathematics paper 2. Okay, let's get right into it. Now it says simplify the expression to a single trigonometric term. Okay, and we're given that. I'm just gonna rewrite that. Okay, let's start with the black pen over there. So we have 10 minus x cos x sine x minus 180. Okay, we need more space, and then there's a minus 1 over there, okay, cool. Now there, to do these sort of things, we need just one thing. We need to know what we call a cast. I don't know what your teacher taught you, but the common thing is just to call it cast. All right. So okay, so let's move on. So 10 minus x, where's minus x? Minus x is on the fourth quadrant, and 10 is negative there, so we're gonna have minus 10x. Cos x is already simplified. Sine x minus 180 is okay. So if x is here and we go minus 180, that means we're going clockwise, and it brings us here to this quadrant, and sine is negative in that quadrant, so we have negative sine x, and then that minus 1 at the end. Okay, so this negative and that negative gives us a positive, so we're gonna have a 10x, which is gonna be positive, and cos x and sine x minus 1. So we want to make sure that we simplify this further. So we are going to change 10x into, you can rewrite 10x into sine x over cos x times cos x over here, and then we have sine x minus 1. So that cos x cancels with that one, and that sine x and sine x gives you sine x squared, and then minus 1. All right, let's just stop it right there. I think that's enough. We can't simplify it any further. So we'll just keep it right there. But what if I can hear you, you are saying you know that, let me just put this in a different color. You know that actually sine x squared plus cos x squared is equals to 1, right? And then what happens if I say sine x squared and I bring the 1 to the other side, becomes minus 1? It means I need to take the cos to the other side, which is equals to cos squared x. If you thought this, then you are right, because that is actually our final answer. Our final answer is equals to, let's go back to black, is equals to minus cos squared x. That's our final answer right there. That's it. Okay, let's go check the next question. The next question says, given, okay, so what I want to do is just, given that cos 35 is equals to m. Now, whenever you get these kinds of questions, okay, 5.2, let's do it in red. Whenever you get these kinds of questions, the first thing you want to do is actually draw your triangle, okay, and then put your 35 there. And they have told us that cos of 35, so cos is adjacent over over hypotenuse, so you must put that divide by 1, so that when you say cos is adjacent, it's equals to m, it's m, and then the hypotenuse is 1. Now this one is always going to be the square root of the hypotenuse squared. Hypotenuse squared is still going to be 1 minus one of the sides squared, which is m squared. Oh, this is under a square root like that. It's always going to be the case. Okay. Right. Now we can go to the questions. The question says cos of 35. Oh, there we go. I actually want the cos of 215. Now we need to figure out 215 in terms of 35. So we'll say cos, I think it's 180 plus 35. Okay, let's just do a quick cast here. We need it again. And then we check 180 is there. 180 plus 35 is in this quadrant, the third quadrant, where cos is negative. So it's negative cos 35. And cos 35 is just simply m. So my final answer is minus m. Okay. And then now let's do 5.2.2. Wow, this one is a bit tricky. Sine 20. Okay, so we have to work this one out in terms of again in terms of 35. So what we're gonna do then is that we're gonna split this into 2, right? So we're gonna have sine, I'll open these brackets, and then I'll have 90 minus 35. 90 minus 35 gives me 55, and then that minus 35 gives me what you might call, gives me 20. Okay, so I'm gonna keep it like this. And also we know we need the compound angle rule. I have them right here, and I'm given, okay, if I have now the sine of let's say a, we have a minus there, minus b, then that's going to be equals to sine a cos b, and then minus cos a sine b. All right, so that's the formula. You'll get this from the formula sheet. I just got it from the formula sheet myself. So let's continue with that. So here our a is represented by 90 minus 35, and then our b is the 35. So then we're gonna say then sine a is 90 minus 35 minus 35, okay, and then cos b, which is just cos 35, minus cos a, remember a is 90 minus 35, and then sine B. Sine B is just 35. All right, so what is sine 90 minus 35? If you remember, let me just give it to you. 90 is over here, okay? And if you say 90 minus 35, it brings you in this quadrant. In this quadrant, sine is actually positive, and a 90 changes a sine into a cos. So then you'll have a positive cos 35. Okay, and then this one it still remains as cos 35. Minus, now cos 90 minus 35 is still on the first quadrant, and in the first quadrant cos is positive, so this negative will remain the same, and then the 90 changes a cos into a sine, so then here you'll have sine 35, and then you rewrite the sine 35 over there. Okay, so what happens from now? This actually, I have, if I look at my this looks very familiar. It's also another compound angle right here. It's negative, so I have that. I'm just gonna write what you'll see in your formula sheet. You will see cos A plus B, which is equals to cos A cos B minus sine A sine B. So this is what will be in your formula sheet. Now, looking at this, you can clearly see that this and that expanded are the same thing. But don't be confused. Don't be confused, because do we need this? If your answer is yes, then you are wrong. We don't actually need this expansion. I know it seemed like we are doing the smart thing, but remember what we're trying to do here is answer this in terms of m. So we already know that cos 35 is actually equals to m times, so I'm just taking it from here, all right? And then cos 35 is m again, minus sine 35. If you look at our triangle here, it's 1 minus m squared under the square root. All right, so we'll just do that. Put it in brackets. Open a square root, 1 minus m squared. Close it, open another one, sine 35 again, same thing, square root, 1 minus m squared. Okay, put it under there. Cool, so this one, m times m is just m squared, just like that. And then this just gets rid of the bracket. I mean the square root times the square root, it gives you what's under the square root. So it's simply that. And then finally, it's m squared minus, get rid of the brackets. So minus 1 times 1 is minus 1. Minus 1 times minus m is a positive m squared, like that. And then finally, we're going to have m squared plus m squared. It gives you 2m squared minus 1. Now, ladies and gentlemen, that is your answer right there. Cool. All right, let's see the next question. Okay, we're done. Determine the general solution of this. Okay, let's just rewrite it down here. Let's use a different pen, a green this time. We're gonna have cos 4x cos x plus sine x sine 4x is equals to minus 0.7. Well, first of all, we need to simplify this. Okay, we need to simplify this. So let's just look at the clues. 4x there, and then I got a 4x here. Wow, this looks very familiar. Do you remember when we wrote this? Cos A plus, that means then if we do minus, this sign is going to be positive there, which is the same as that. So this is a compound angle, and it's going to be equals to cos, and then you'll have 4x minus x. Okay, and they're coming from these things over here. Okay, and there's a plus, so the plus for a cos, it's a minus when compounded. Okay, all right, so from there we can continue then. That's equals to minus 0.7. So finally this is cos 4x minus 3x, I mean x is equals to 3x, which will be minus 0.7. Okay, so from here we can get our reference angle. Reference angle, for that we need a calculator. Let's get a calculator real quick over here. There we go. Okay, calculator, what do we need you for? So we're gonna say shift cos, and then we'll put 0.7. I don't do the one where I put the negative sign. I do the one where I do a positive sign, and then you'll see how that works out at the end. So our reference angle is 45.57. 45.57. 45.57. Okay, so that's our reference angle. Okay, if you don't know how we got our reference angle, all we did was just to say the inverse cos of 0.7. Okay, and then it gave us that 45. Now you need your cast once again. Now we are looking for in the cast, we're looking for where cos is negative. Okay, and we know it's negative in this second quadrant and the third quadrant, because of the first and fourth cos is positive. All right, so how does this help us? Check this out. Then we can then say, let's start with the second quadrant. We're gonna say second quad, and then we will say in the second quadrant we know that 3x is equals to remember we have a 180 here, so second quadrant is 180 minus the reference angle, which is 45.57, plus k 360, to say that it repeats itself every k 360, and this is where k is an element of an integer. Okay, cool. Integer is whole numbers like 1, 2, 3, 4, but just a whole number, not a decimal, or -1, -2, a whole number. All right, so we need a calculator over here. Let's get that. So we're gonna say 180 minus 45.57. That gives us, give me a decimal, 134.43. 134.43. 134.43 plus k 360. Now this is equals to 3x, but we need the x, so we'll divide everything by 3, even this side, so that we'll have x is then equals to, we need a calculator again, so we'll just divide that by 3 and it gives me 44.81. okay, 44.81 plus k, 360 divided by 3 is 120. Okay, so that's our one answer. We need to do the same then for the third quadrant. So we'll have 3x is equals to 180 plus 45.57 plus k 360, where k is an element of an integer. All right, we need the calculator once again. Let's just get it, and this time we're gonna say 180 plus 45.57. that gives me 225.57. Good. 225.57 plus k 360, and remember this is equals to 3x, so we need to divide everything by 3 like that, and then we'll be left with x is equals to need that calculator again. Okay, so we'll have to divide this by 3, and then we have 75.19. okay, 75.19 plus k 360 divided by 3 is 120. So these are my two answers, my general solutions right over there. That's it. Let's go check out the next question now. The next question says prove that, okay, so I have to prove the left hand side is equals to the right hand side. Let's start with the left hand side. Okay, which pen am I'm going to use blue. I have to go look at that thing so far. Maybe if I studied up here. Yeah. So the left hand side is sine 4x cos 2x minus 2 cos 4x sine x, and then cos x, and all of this is divided by tan 2x. All right, need more space, so I'll study it over there. So that's going to be equal. Okay, let's look what's common between these two. Okay, nothing really. I thought there was something common. So what we're going to do then is that we're going to rewrite this one. The first one for x cos 2x. Now here, if you look at your formula sheet, you will see, let me look at my formula sheet. You will see that actually sine 2x is equals to 2 sine x cos x. All right, and there we have it here. We have that's the 2, and then that's the That's the sine x cos x. So let me just do it like this, combining those, then let me just write the cos x first, cos 4x, and then those will give me then sine 2x. Okay, so now I have 4x and 2x on both sides. Now if I go to my formula sheet and check, what does that give me? What is that? Now if I look at actually minus, okay, if I look at that, we did it here actually. If you look at this one over here, remember this, sine a minus b is equals to sine a cos b. So in this case, a is 4x and b is 2x. So I can rewrite this then as sine 4x minus 2x. Okay, I just rewrote it because formula sheet gives me this thing over here. So in rewriting that, then I'm left with sine 4x minus 2x gives you 2x. Now is this equals to the right hand side? Not really, because we are not done. This was just the top part that we're doing there. So let's divide that by 10. 2x. Actually, even here, all of them should have a 10 2x, because we're really just simplifying the top. All right, so here we go. And then remember that we can rewrite 10 as sine over cos. Okay, and then we need to simplify that further. We're over there now. And simplifying this further, we're gonna say sine 2x. Remember, it can be divided by 1, and then we're going to multiply, and if we change this into a multiplication, we'll do the reciprocal, which is going to be cos 2x divided by sine 2x, and then the sine 2x's cancel each other, and you're left with cos 2x. Okay, is this now equal to the right hand side? No. Why? That means we need to simplify the right hand side. Now the right hand side is actually, let me just write right hand side is cos squared x minus sine squared x. If you look at your formula sheet, that is actually equals to cos 2x. And now I can therefore conclude that my left hand side is equals to my right hand side. Okay, both of them are equals to cos of 2x. Okay, was that the last question? Oh yes it was. Yes it was the last question. Well, ladies and gentlemen, thank you so much for tuning in. But in the event you didn't understand something that I did, feel free to contact me and have me as your tutor. You can contact me on my website www.mvtutors.co.za and book a free consultation session there, or you can WhatsApp me 1076 312 1107. You can also comment under this video and book a session there. It's up to you. It's easy to get a hold of me, and I would love to help you further. Well, that's it from me. Enjoy the rest of your day.
Hello everyone and welcome to MV Tutors. I'm Tsulu and I'll be looking at question 6 from the supplementary that was written in June this year. Alright, so let us see. In the diagram below, the graphs of f and g are drawn for the interval from negative 180 degrees to 180 degrees. Okay, so A and B are 2 points of intersection of f and g. Alrighty, so we can see here that if, what did I do now? Okay, so we can see here that if, this is if here, it's a cos graph that has a period that has changed. Instead of one wavelength being produced over 360 degrees, you have one wavelength produced over 180 degrees. So the period has changed. That's what the two did there. And then for G, we actually have a sine graph, but it's negative. So it's inverted. Okay, previously you would have at 90 degrees, you would have positive 1. But because now it's negative, you have it at negative 1. Okay, now let's see. What are they asking us here? 6.1. Without using a calculator, determine the values of x for which cos 2x is equal to negative sine x. So basically, we're already dealing with where A and B intersect, or where A and B have the same x and y values. Sorry, what am I saying? Where f and g, the graphs of f and g, where they intersect, which is at A and B, or instead of saying the word intersect, where do they have the same x and y values? So that's at A, at B, and also at this point here. So here they don't really cross, they don't intersect, but they touch at the same x and y values. And when we get our x, when we calculate it without using a calculator, we have to at that point get 3x values. Okay, so let us see. I have cos 2x is equal to negative sine x. Okay, cos 2x, if you remember the identities, you'd know that for cos 2x, a double angle, you have 3 solutions. Okay, you either have cos squared x minus sine squared x is equal to, no, not equal to anything. Cos 2x is equal to cos squared x minus sine squared x, okay? Or you have the option of 2 cos squared x minus 1, or you have the option of 1 minus 2 sine squared x. Those are your 3 options. Okay, looking at what we have on the right hand side of the equation, I have a sine x. Okay, so I want the identity that only has sine, and that is the last one here. So that's what I'm going to substitute. Okay, 1 minus 2 sine squared x is equal to negative sine x. And then I'm going to take everything to the other side. So I have 2 sine squared x minus sine x minus 1. Okay, and there I see I have a quadratic equation. Okay, I can use my quadratic formula, or I can just factorize. And if you are struggling at this point because there are trigonometric expressions, then I would advise, instead of maybe having a sine x, maybe have another variable apart from x. Okay, let's just use y. So I could, this is the same as saying 2y squared minus y minus 1. Okay, so this is something you are doing on the side. Okay, if you want to formalize it, you could then say let sine x equal to y, so that you can guide your marker and they're not confused, like, We had sine x, all of a sudden it's y. What's happening? Why? Okay, so if I were to use y, okay, which is what I like doing, because yeah, sometimes having trigonometric expressions, it can be a bit much. Okay, so I have 2y on one bracket and I have 2 in the other, and I have 1 and I have 1, right? Because I need to get 1 at the end and I need to make sure I have 2y squared. But because I have a negative sign here and a negative sign here, I have to have a plus and a minus somewhere. So where will what go? If I take 2y times 1, I want it to be negative, because minus 2 plus 1 will give me minus y. And that's why I go with that option. Okay, but remember, I was using the y's to just help me with the signs. So in actual fact, this would be 2 sine x plus 1. And then I would have, what did I do there? Sorry, I made an error. I'm supposed to put y. Okay, not 2. Sorry about that. Okay, on this side I have sine x minus 1. And if I solve it, I have 2 sine x is equal to negative 1. Therefore, sine x is equal to negative a half. And this side I have sine x is equal to 1. Okay, now I need to get what the value of x is, which are my reference angles. So I'm just going to divide the 2 here. So my reference angle, it's going to be negative 30, because sine 30 is a half. So sine negative 30, that's actually going to give me negative a half. Sine negative 30 will be negative a half. Okay, sorry about that disturbance. Alrighty, and then sine, okay, so without even looking at this negative here, let's just hide the negative if possible. So if I were to hide the negative, okay, I know that sine is positive in the first and the second quadrant. Okay, I hope I don't lose you here. So I am using, okay, I'm gonna refer to the first and the second quadrant. Okay, so because I got the reference angle for the full value here, which is negative a half, I will have to use quadrant 1 and 2. If I ignored the negative there and I solved that x is actually equal to 30, I would then have to say this negative means that sine is negative in the third and the fourth quadrant. So it's up to you whether you use x is equal to 30, but make sure it's in the third and fourth quadrant because that's where it's negative, or you use your value as it was, okay, the negative a half, and you know that sine is positive in the first and the second quadrant. I really hope I didn't lose you there, but if I did, please comment below and I will gladly explain to you individually. Okay. Okay, so then I'm going to use the first and the second quadrants. So in the first quadrant, I know that x is equal to negative 30 plus 360 times k, where k is an element of integers. Okay, if I were to substitute minus 1 next to for k, I would have minus 30 minus 360. That is a big value. It is not found within the domain given to us, which was negative 180 and 180, positive 180. So that wouldn't work out. But if I substitute 0 for k, then yes, my answer would be x is equal to negative 30, which is within the domain that they gave us. If I were to use positive 1, it will of course fall out of that range. Okay, so then my answer there would be x is equal to negative 30. That's my first solution. So I can see, okay, that's where B is. So that's negative 30. Now if I look at the second quadrant, I know that it's x is equal to 180 minus 30. Okay, plus 360 times k, where k is an element of integers. If I add that up, 180 plus 30, that's actually 210 plus 360 times k. Now here, if I substitute the value, let me just say k is equal to 0. If I substitute in the value of k is equal to 1, what value would I get? So then, let me start with negative 1. If I substitute in negative 1, I'm going to get 210 minus 360. And if I say, what is 210 minus 360? That'll give me negative 150. So I have there x is equal to negative 150 because it is within the domain of negative 180 to positive 180. But if I substitute 0, I'm going to get x is equal to 210. It falls out of the range. If I substitute 1, I'm going to get what, 570? So no, the only answer then would be negative 150. And I see that is where A is, negative 150. Now if I come to the other side where sine x is equal to 1, the reference angle there is going to be 90. You can check on your calculator. So sine again is positive on the first and the second quadrant. So if I go for the first quadrant, I would have x is equal to 90 plus 360. This is like the general solution, okay? K is an element of integer. And this is why the question is actually 6 marks. You are gonna work. Okay, so if I substitute 1 in there, I'm gonna get a very big value. Not gonna happen. If I substitute 0, yes, that would work out. My answer would be 90 degrees, okay, for k is equal to 0. If I substitute negative 1, still outside of the boundary of negative 180 to 180 degrees. So my third answer would be 90 degrees. If I go to the second quadrant, do you realize the second quadrant is 180 minus the reference angle, which is 90, and, okay, 360 plus, where k is an element of integers. This 180 minus 90 is going to be 90, so we're back to that. So we're done solving. Okay, this third answer there, it's actually 90 degrees. So yeah, those are the x values that they asked for 6.1. Quite a lengthy question, but yeah, hopefully the others go quicker. Now it says use the graphs above to answer the following questions. How many degrees apart are point A and B from each other? Okay, so the nice thing is you already drew it for yourself. You know that A is actually negative 150 degrees and 0. And you know that B, no, I'm lying. It's not 0. It's not the x-intercept. It's actually a certain y value. Okay, and then B is negative 30 degrees and a certain y value. Those y values are actually the same. But because we're looking for the degrees that they are different or apart, I'm just going to say the x value for B minus the x value for y, which is the negative 30 minus 150. That will give you 150 minus 30, which is 120 degrees. So yes, distance, or rather the degrees apart, you can't give a negative value there. It will have to be positive 120. Okay, and then 6.2.2, for which values of x in the given interval will, okay, times, so f prime and g prime, if we multiply them, they are actually bigger than 0. Okay guys, don't get scared if you see this. Remember in paper 1, part of your calculus, if they wanted this is like saying the first derivative Okay, so the first derivative would actually be equal to your gradient. That just tells you about the gradient. Okay, so don't be nervous, don't be scared. It's just getting the gradient. And the gradient really talks about how steep something is. Okay, so now for us to get a value that is bigger than 0, it means your value has to be positive. And what is it that gives us a positive value? It's when you have a positive times a positive. Also, when you have a negative times a negative. That is how you will get a positive value. So basically, you want gradients that are both negative on the same interval, x interval, and gradients that are both positive on the same interval. Okay, so I'm just going to highlight here the negative gradients. So at a point there where it's flat, there's no gradient, it's actually 0. Okay, so it's flat here, no gradient, but it actually starts going down here until again it reaches a 0 point. Okay, that is for the graph of f. For the graph of g, again, that's where you have a negative gradient. Again, the graph of f, that's where you have a negative gradient, and that is it. Okay, so now if I'm looking for the positive gradient, I'm just going to choose a different color. Okay, the positive gradient for g will be here. Okay, and again we go there where it becomes 0 there at x is equal to 0 degrees. It goes positive again, and it goes positive. If you want to know which is a negative gradient, which is a positive gradient, if from left to right you are going up, then it is positive. If from left to right you're going down, then it's negative. So now, like I said, we need to go look for the ones where we have both positives and both negatives. And you can see that from 0 degrees, okay, up until 90 degrees, that's where you have negative gradients that will give you a positive. Then from 90 degrees to 180 degrees, you have positive gradients that will give you a positive value. So ultimately, you have x in between 0 degrees and 180 degrees. Okay, I am not including the equal sign because that's where the gradients are 0, and we are looking for the gradients. When you multiply them, you get a positive number, not a 0. Okay, another way of writing this, you could have said x is an element of 0 and 180. Okay. Okay, the last question. We're almost there, guys. All right, so determine the values of k for which cos 2x plus 3 will equal k. Okay, so basically you have taken this graph and moved it 3 units up. Okay, and now they want to know where will it not have a solution. Okay, guys, so for your normal cos or even a sine graph, you have limits. Your range is limited. Okay, y can only be an integer of -1 and 1. Okay, look at this graph. Okay, this is cos 2x. The minimum value here is -1. The maximum value is 1. You cannot get out of that range. Anything outside of the range will not have a solution, unless if your amplitude is a certain number. If your amplitude is 2, then yeah, you can go from -2 to 2. Okay, but your amplitude here for your graph is 1. So you cannot go above 1, nor can you go below -1. Okay, anything below does not have a solution. Anything above does not have a solution. Even cos 2x. So even if you change the period, your range will still remain. You cannot go above 1. You cannot go below -1. Okay, so basically, I would rewrite this and say cos 2x equal to k minus 3. Now I know for me to have a solution, k minus 3 must be in between and equal to -1 and 1 for there to be a solution. Okay, so for there to be a solution. Now for there to be no solution, I know that k minus 3 has to be bigger. Sorry about that. K minus 3 has to be bigger than 1. Or k minus 3 has to be smaller than minus 1. That is where we can't have a solution. And then what are the values of k? I would have k is bigger than 4, or k is smaller than 2. Okay, let me try sketching it for you, just so that it makes sense. Okay, let me use the color green this time. Okay, so this is your graph, ne? Cos 2x. So if I move cos 2x 3 units up, this was 1. So let's say this is 2, and that's 3. Okay, now I'm going out. And that is 4. So it'll be 4, right? Because I added 3 to 1. Here I had negative 1. So if I add 3, I'm going to be at 2. Okay, so those are my values at 4, at 2, and then I'm back at 4. And then here again, where am I? Yeah. 2, and then here it is 4. Okay, so this is my new graph, right? This is the graph that I shifted. Okay, now what values of k will make sure that I don't have a solution? Basically anything above 4. Okay, so anything above 4, there won't be any solution. And again, anything below 2, there won't be any solution. So that's another way of looking at it. You can actually sketch it for yourself and see where there is no solution. And that is it for question 6. I hope you guys understood. I can see I'm like sweating, or rather my skin is so shiny. But yeah, I hope you guys learned something and that you enjoyed it. I'll see you guys for another question. I don't know what that will be, but yeah, later.
Well, hello there. How are you doing? I trust you're doing very well. My name is Figa and I am MV Tutors. Welcome to our channel. Well, we are now doing question 7 of the Mathematics June 2021 exam. And we are trying to explain this memo. We're given the memo and we're trying to explain it in a more digestible way. Okay, so what do we have here? This, it says point B, C, and E lie in the same horizontal plane. B, C, E, okay, I see them, horizontal plane right there. And then it says ABCD is a rectangular piece on the board, piece of board, ABCD, okay, I see that rectangle. Always read these things to get clues, okay? CDE is triangular piece of board having a right angle at C. So let's find CDE. Okay, we see it there, right angle, got it. Each piece of board is placed perpendicular to the horizontal plane and joined along DC. Okay, so these two pieces are horizontal, as you can see. Join as shown in the diagram. The angle of elevation from E, let's see E, there is E, to D is X. Okay, I see that on the horizontal plane. BEC, let's find BEC. That's B, where's E? E, there we go, and C. Okay, BEC is 2X. Okay, it's shown, and EBC is equals to 30. All right. Okay, so with this topic, there are a few things that you need to know, be aware of. Is that if you have, if you have a right angled triangle, okay, and it's right angle right there, okay, Then for a right angle triangle, you can use SOHCAHTOA. I hope you know what SOHCAHTOA is. And you can also use what we call Pythagoras. This only applies if you have a right angled triangle. But if you have a triangle and it's not right angled, it's just a triangle, okay, and this triangle, say it has, let's call this no, let's call it as angle A, B, C, and then opposite A is side A, opposite B is side B, opposite C is side C. Then you can use the sine rule, and also you can use the cos rule. Okay, so you should be able to distinguish between what type of triangle you have. You can't use Pythagoras or SOHCAHTOA if the triangle is not a right angled triangle. Okay, so that's one thing you have to know. Okay, so now let us read the question. It says 7.1, show that DC is equals to that. Now, whenever they ask you this question, don't worry about this, what it's equal to yet. Just solve DC as though you were solving it normally. Okay, so where is DC? DC is over here. They want us to solve for this angle. But to solve for that, we need a triangle. So let's say we'll take this triangle over here. Okay, first of all, let's see. What do we have here? We have X and DC is opposite X. That's all we have. There's nothing else that we have. Okay, which means it looks like we can solve for CE. We need to solve CE. Now, to solve CE, we're going to have to use this triangle over here. We use this triangle right there. Okay, this one here. Okay, so normally what I like to do is that once I've identified which triangle to use, I also draw it at the same time in a more simplified way. So then I would come here and say that green triangle is actually like this. Okay, let's say it's like that. And then, so it's obviously not a right-handed triangle, but that's C, that's B, and then that is E over there. And we are told at E we have 2x, and at B we have 30 degrees. Okay. And then what do we have? We want CE. Okay, so we want CE. All right. So how can we solve for CE? If it's not a right-handed angle, then we can use either the sine rule or the cos rule. You can find these rules under your formula sheet. All right, so here, because we have two angles, that means we can use the sine rule, and we're looking for the side. So then we'll say CE. Let me use a different color there. Let's go for red. So then we will say CE. Let me just write the sine rule as it is CE, yeah, and the angle opposite CE is 30. That's going to be equals to CB or BC. What did they use? They said BC. Let me just stick to what they use as well. BC so that it will be easier to identify, divided by sine opposite BC is 2x. Okay, so all that's left for us to do now is some mathematical gymnastics. And so we're gonna say CE is therefore equals to BC sine 30, right, divided by sine 2x. Now sine 30 is a special triangle. If you remember your special triangles, it's right. Okay, if it's like this, it's always a right angle triangle. Then if you have your special triangle is 30 there, 60 there, adjacent of 30 is square root of 3, and then here we have a 1 and a hypotenuse is 2, 1, 2, 3 square. Okay, that's cool. So when we look at sine 30, sine is opposite of a hypotenuse, so the opposite of 30 is 1, and then the hypotenuse is 2. So here, instead of sine 30, we'll replace it with 1 over 2. That becomes BC. And then 1 over 2, there's a 1 there, and then the 2 comes to the bottom. And then we have sine 2x there. Okay, so what have we done right now? All we've done is just solve for CE. So now I want to redraw this blue triangle. And let me just do it over this side. Okay, so let me grab the blue pen. And the blue one is like that. It's like this. There we go. And it's a right angled triangle. Okay, so which means it's like that. And then we have D here. And then we have C. And then we have an E over there. Okay, what else do we have? We have an X. We know that's X over there, that angle there. And we have CE. CE we just solved to be, we just solved it to be BC divided by 2 sine 2x. Okay, there we go. Just make this longer. Cool. So now we are interested on DC, right? So we can use, remember, if it's right angled triangle, then we can use SOHCAHTOA and Pythagoras. We can't use Pythagoras because we have an angle here, so we're left with SOHCAHTOA. Looking for DC, in SOHCAHTOA, we can use tan, because tan x is equals to the opposite, okay, divided by the adjacent. All right, so we'll have tan x is equals to, the opposite is DC, what we are looking for, divided by the adjacent, which is BC, divided by 2 sine 2x. Okay, let's bring it a little bit there. Okay, so now we have to do some mathematical gymnastics once again. We want to make DC the subject of the formula, so I'll just bring it this side so that we'll have DC is equals to BC over 2 sine 2x, but remember we have a tan, so we'll multiply this whole thing with a tan x. Okay, we'll just continue with our gymnastics over this side. And then tan, remember you can always write tan as sine x divided by cos x. Okay, and then we've got BC over here. Oh, where should I write it? Let me write it on the other side. BC. Okay, so BC times sine x cos x. And then all of this is divided by 2. Now remember, 2 sine x expanded, we can rewrite it as 2 sine x cos x. All right, there we go. Let's do some more gymnastics. BC sine x divided by cos x. Now I like to, whenever I have fractions, I like to have 4 of them. So this is like it's divided by 1. What this helps me to do is that now I can isolate. Okay, that is one term, and that term is the one I'm going to multiply. And remember, when you multiply, you reciprocate, you take the reciprocal of this, so then it becomes 1 divided by that. So 2 times 2 is 4. So what I really have is 4 sine x cos x. All right, so now I can cancel, because it looks like the signs will cancel. So that sign cancels that one. And then finally, I'm going to be left with, let me just give myself more space. Let's bring it here. Let's do it this side. Okay, and then finally I'll be left with BC divided by, there's a cos x here, a 4, and another cos x, so that's 4 cos squared x. All right, is that our final answer? We can always go and verify. Is it the same as what we're given? Absolutely. For 6 marks, we did a whole lot of work, as you can see, but we got the answer eventually. All right, so that's how you do that question. Let's go check out this question now. Now they say, if x is 30 degrees, show that the area of ABCD is 3AB squared. Okay, so first of all, let's just solve for the area of ABCD as we would normally. Okay, so I'm gonna do it this side. I'm gonna say this is 7.2, right? I'm gonna say the area of ABCD is equals to length times a breadth. Now what is our length? Our length is BC. Our breadth is DC. Okay, so let's just solve for that. BC, well, let's keep it as BC. DC, we solve for DC in terms of BC, or just use the one that's been given in the question. That one, it's actually BC divided by 4 cos squared x. And then here, BC times BC, that is just BC squared divided by 4 cos squared x. But now they told us that x is 30 degrees. So let's substitute 30 for x, so that we will have BC squared over 4 cos squared, and x is 30. All right, that takes us back to our special triangle. Let's check cos of x of 30. Cos of 30, you can see, is adjacent of a hypotenuse. Adjacent of 30 is square root of 3 over 2. So we'll do just that. My bad. So we will say BC squared divided by 4 cos, oh no, but we just figured that out, that cos 30 is actually square root of 3 divided by 2, and it's squared. Eventually we'll have BC squared. Let's simplify it further. We have that 4 square root of 3 squared is just 3, and then 2 squared is 4. So finally we'll have BC squared divided by, these 4's will cancel each other, so it's divided by 3. Okay, let's go see if it's equal to what we were given on the others on the question. Oh, it's right here. Bad. The question said the error must be 3ab squared. We are not getting anything ab squared. Okay, it's very different. So what do you do if something like this happens? Well, then you treat it as a normal proof. So this is the right hand side. Okay, now we need to prove the left hand side, which is 3ab squared. Okay, so here then we would say let me just put it now. This is the right hand side. Okay, now what I want to do is solve for the left hand side. Okay, so let's do it right here. We're gonna say let me use a different color. Let's go for red. So the left hand side, we have 3ab squared. Okay, that's what we have to prove now, 3ab squared. Okay, what you have to notice about AB is that AB is actually equals to DC. Okay, so we can then say 3ab squared is equals to 3 DC squared, and the reason is because AB is equals to DC. Okay, that's the reason. So now all we have to do then is take the DC. DC was there it is again, substituted over there. So DC is actually, let's put it in brackets so that we'll square it. It's BC divided by 4 cos squared x. Okay, and this whole thing must be squared because it must be squared. And then we can work with it again. 3, we remember we solved it over here. Substituted the 30, so BC, it became square root of 3 over 2, and then eventually it became you know what, let's just do it, let's not skip steps. So this is gonna be BC over 4 cos squared of 30. Okay, and this must be squared, and then 3 BC over 4, and then we said cos of 30 squared is actually equals to 3 over 4, and then these 4's will cancel each other. This is still squared, so then eventually we'll have 3 BC over 3 squared. Okay, we can work with that, and then eventually we're gonna have we can square it now. That's gonna be 3. BC squared is just BC squared, and then 3 squared is 9, and then eventually the 3 cancels with the 9, because that's on top, and then you'll have BC squared is equals to 3 goes to 3 once, 3 goes to 9 3 times, so BC 3. It's looking clear now, and this is the left hand side. So now we can conclude and say, therefore, left hand side is equals to, let's change color, the right hand side. That's it. Both of them, they give you the same answer, as you can see, and that's how you deal with it. But in the event that you didn't understand anything or something confused you here, I'll be glad to be your tutor. So contact us via our website, www.mvtutors.co.za. Book a free consultation over there, or you can WhatsApp me on 076 312 1107. Well, that's it from me. Thank you very much, and I'll see you next time.
Hello everyone, and welcome to MV Tutors. I'm Solo, and I'll be looking at question 8 with you guys. We're still looking at the June Supplementary 2021 exam. Alrighty, so let's see what we have here with Euclidean geometry. So it says in the diagram, MP is a diameter of a circle centered at O. It's always nice when you have a center and a diameter. MP cuts the chord NR at T. NO and chords PR, MN, and MR are drawn. Okay, and then R1 is 69 degrees. Okay, so what the question says, determine, giving reasons, the size of R2, O1, M1, M2. So I'm just going to note those ones. Okay, and then what did I do now? Press the wrong button. Okay, so I'm just going to highlight them. So we need R2, O1, okay, O1, M1, and M2. If it is further given that NO, okay, is parallel to PR. Okay, so let us see, how are we going to do this? So first of all, we have a diameter, right? And what do we know about when the chord becomes a diameter? When the chord becomes a diameter, the angle it subtends is 90 degrees. Okay, so this one here is 90 degrees. So we can already say 8.1.1 R2 is actually equal to 90 degrees minus 69 degrees, because R2 and R1, when you add them up, they need to give you 90 degrees. Okay, so we can then say that is 21. Okay, yes, it's 21 degrees. Alrighty, and we need to provide reasons. So we need to say, so the angles subtended by diameter equal 90 degrees. I think there's a shorter explanation for it. I think chord diameter, something along those lines. Listen, if you forget the shorter versions, you can write a paragraph as long as you get those marks, okay? Now we look at O1. Okay, So again, remember that when you have a circle with the center, the angle at the center is twice the angle at the circumference. So which chord would be subtending those angles? We have chord MN. So chord MN subtends O1, and it also subtends R1. Okay, so we know that O1 is actually twice R1. Okay, and the reason for that is angle at center. If you want to write the long version of it, to say that the angle at the center is twice that of the angle at the circumference, provided that it's subtended from the same chord, you can do that. But I'm just going to say angle at center. Okay, we already know that R1 is 69, so we're just really doubling it. So what is 69 times 2? Well, 70 times 2 will give you 140. Minus 2, we get 138. So 138 degrees. Okay, and then 8.1.3. Now we're looking for M1. Okay, I'm going to choose a different color. That's the thing about Euclidean geometry. You need highlighters there because you can get lost in what you're doing. So M1. Okay, we already know that O1 is 138, right? And we know that OM is a radius as well as ON. So ON and OM are radii, okay? Meaning they have the same length. And if they have the same length, remember we have an isosceles triangle. Okay, so isosceles triangle, basically you have the same lengths there, and you also have the same angle. Okay, so if I have 138 there, and I know that if I add all these angles up, let's just call it x. So I have 2x plus 138. That should give me 180. Okay, so yeah, so basically we say that M1 is equal to N1, right? And that is because we have an isosceles triangle. Okay, isosceles triangle, or rather let's just say isosceles triangle. The triangle is OMN. Yeah, okay, let's just say isosceles triangle and then in brackets triangle OMN. Okay, so now to get this x, so I will say 2x is equal to 180 minus 138. Minus 138 degrees. So 180 minus 140, that's 40, minus 2, that's 38. Okay, no, I'm kidding. Let's just use the calculator. So 180 minus 138 should be 42. Ne? Yeah, it should be 42. Okay, and then we know that actually x is going to be equal to 21 degrees. Okay, it's the same. Is it the same? The same as R2. Yeah, I suppose. Let me just check. We have a calculator here, but yeah, it should be right. So I have 180 minus 138, 42, divide by 2, that's 21. Yeah, I don't know why I'm doubting myself. So yes, x is equal to 21 degrees, and we know that that is equal to N1, which is equal to M1. Okay. I'm trying to see if we could have related M1. But anyway, 8.1.4. So now we need to get M2. Okay, so we need to get M2. if it is further given that NO is parallel to PR, so let's go at it again. So M2 is here, okay, and they told us that these two are parallel. So if these two are parallel, I basically have a Z there, okay, which indicates alternating angles. So I know that O2 is equal to P. Okay, that doesn't help me at all. So let's try the other Z. Okay. So yeah, if we try the other Z, but do we even need it? So I have R2 over here, and I have N2. Okay, and then what else do I have? What else do I need? If I'm to get M2. So I am, let me just think about it. Okay, so if I have a look at triangle MNR, okay, I know what R1 is, right? That is 69. I know what N2 is, okay, so N2 is equal, let me just write as I go. So N2 is equal to R2, okay, which is equal to 21 degrees, and that is because of alternating angles, and which lines are parallel. NO is parallel to PR. Okay, so now I know N2 is 21 degrees, all right. Then I know that N1, which we previously calculated, that's also 21 degrees. Okay, so now I have the full N. So I have the full N, I have R, and I also know that M1 is 21 degrees. So my only unknown really is M2. So therefore I'm going to say in triangle MNR, so I have that R is equal to 69. Okay, so that's given. And then I know that N is equal to N1 plus N2, which will be equal to 42 degrees. Okay, and then I also know that, so therefore M should be equal to 180 minus 69 minus 42 degrees, and that is the sum of angles in a triangle, or in triangle MNR. Okay, so now we know that M consists of M1 plus M2, right? And then if I take, okay, we're going to use the calculator. We're not even going to try to solve it in our minds, lest we make stupid mistakes, or lest I make a stupid mistake. So we have 69. Okay, yes, so we have 69 there. And I know that M1 is 21. So I have 69 minus 21 degrees. All right, so M2 then will finally be 48 degrees. Okay, and we have given all the reasons that are required. Okay, cool. Okay guys, so I actually saw another way of getting M2. I actually forgot. Remember that we have this right angle triangle? So that's another way of getting it. So here we know that we have 90 degrees. And this P, okay, so that first Z I was talking about, it actually does count. So if you want to get O2, you know that O2 Okay, so I could say or. So I know that O2 plus O1 is actually equal to 180 degrees, and that is angles on a straight line. Okay, and O1 is 138, so O2 is 180 minus 138, and that is then equal to 42. Yes, 42 degrees. So I know that P is actually 42 degrees. So in my right angle triangle, oh gosh, okay. So in my right angle triangle, I know that I have 42 degrees. And if I want to get that one, I'm going to have to sum up my angles in a triangle. And I know that M2 plus R plus P should be 180. And that is sum of angles in a triangle. Okay, so I know that M2 is actually equal to 180 minus 90 minus 42, and that will give me 48 degrees. So that's I think another simpler way of doing it, but yeah, you get the same answer. So now we get to the second portion of question 8. Okay, still gonna scribble a bit. All right. Sorry about that. So in the diagram below, ABCD is a cyclic quad. Okay, I think I need to make that clear. So we have that ABCD is a cyclic quad. All right. AB and DC are produced to meet at E. AD and BC are produced to meet at F, not 4F. AFB is 2x, so we see that here. We have the 2x. DAB is 3x. And AED is x. Okay. What do they want us to do? What is the question? The question is, determine, giving reasons, the value of x. Alrighty, what is the value of x? So we're going to have to look at this up close and see what we can actually determine. Okay. So we have this big triangle, one of the big triangles, EAD. Okay, I'm just going to draw it on the side. So I have triangle EAD. Okay, and with that one, I have 3x. I just have D2. And I have x. Okay, so that is E, and that's A. Okay, so what else can we see from it? So if I were to look at the external, so if I were to look at C1, this is an external. So C1 is actually equal to 3x. Okay, so I know this is 3x because an external angle in a cyclic quad is equal to the interior opposite angle. Okay, so that is that. I also know that D1, okay, D1 is equal to B2. We don't have anything there. If I look at, what else can I see? External angles, B1 is equal to D2, no. Okay, if I look at, which one? Oh, so C1 is 3x, and vertically opposite angles, I also have 3x here. Okay, but does it help me anyway? Not really. Okay, so I have C1, I have C3. Yeah. Okay, if I had a look at B1, okay, I'm just gonna point out that B1 is actually equal to D2. Where that takes me, I don't know. Okay, so I know that B1, again, external angle to a cyclic quad is equal to the interior opposite. So it's equal to D2. Alrighty. And then, so, actually I think I'm onto something. So if I were to draw out okay, so I have E here, and that's X. I have B1, okay, and B1 is equal to D2. And then I have 3X here, which is C. Okay, so I thought I was onto something. What did I see? Now I'm not seeing it anymore. So B1 is equal to D2. Oh, I was thinking of angles, the sum of angles in a triangle. That if B1 would be 180 minus X minus 3X, and that will be equal to D2. But that doesn't help us still. Okay, but D2, guys, D2 is an exterior angle to triangle FCD. Okay, so if I drew the triangle CFD, however way you wanna look at it, so I have C, I have D, I have F. Okay, so F is 2X, C there 3X, then we have D1. So do you see that D2 is an external? D2 is an external angle to a triangle. And what do we know about external angles to triangles? We know that an external angle of a triangle is equal to the sum of the opposite interior angles. Okay, so I will start there. Let's start with C1 because we need to give reasons. I've just been writing stuff. So C1 is equal to 3X, right? Because it's the interior, no, sorry. It is the exterior angle of cyclic quad. Okay, and then C3 is equal to C1, which is equal to 3X, and that we call not alternating angles, vertically opposite angles. Is that what we call it? I think I forgot. Vertically opposite angles, that sounds wrong. Yeah, well, opposite. What is the actual word? I think I gave a reason, but I really forgot. Okay, so it is, yeah, opposite angles. I forgot. I literally did. I'm sorry, guys. Okay, and then what else did we conclude? We then concluded that D2 is equal to 5X because it is the sum. So exterior angle of triangle is equal to sum of interior opposite angles. Yeah, I think this is vertically opposite. Alrighty, and then if I have D2, okay, so if I have D2, going back to my triangle, yes, okay, let me just copy it just to save time. So, okay, copy and paste. Okay, so now I have D2 and we know that D2 is 5X. Okay, so D2 is actually 5X. Okay, then I think we're ready to solve. We're ready to solve, guys. So then x plus 3x plus 5x, that is equal to 180. And then we know that sum of angles in a triangle equal to 180. Okay, so we have 4x plus 5x, that is 9x, that is equal to 180. Therefore, x is equal to 20 degrees. And we are done, I believe, with question 8. Is it? Yeah, we're done. This was 6 marks. Okay. It wasn't as bad as I thought. So yeah, I hope you learned something here. Until next time, bye. Hello everyone, and welcome to MV Tutors. I'm Tsulu, and I'll be looking at question 9 with you guys. Alright, so what do we have here? In the diagram, ABC is a triangle. Okay, D and E are points on sides AB and AC respectively, such that DE is parallel to BC. Use the diagram above. Use the diagram above to prove the theorem which states that a line drawn parallel to one side of a triangle divides the other two sides proportionally. So here we are going to prove the proportionality theorem. Okay, let us attempt this. All right, so this is like one of those theorems that they love asking, so please make sure you know it. Actually, just highlight all the theorems you should know. Any one of those could come out. So now I'm gonna look at triangle ADE. Okay, because yeah, I want to look at triangle ADE so that I can get AD and AE, just to see how I can try that. Okay, so if I look at, I want to get the area of triangle ADE. Okay, and if I do that, I'm gonna need a perpendicular height, because you know that the area of a triangle, it's actually equal to half base times height. Okay, so in this case then, what am I doing? Okay, yeah, so we're gonna look at half base times height. So if I'm gonna look at triangle ADE, okay, and I'm sort of like trying to get the AD portion. Okay, so if I look at this triangle ADE and I'm looking for a perpendicular height, okay, I will actually, if I wanted to end there at E, I will get something like that. Okay, of which I'm gonna name this as my H1. Okay, and if again I want to look on the other side, AE being my base, the perpendicular height will actually be something like that. Okay, maybe I should have used a different color. Yeah, let's do that rather and not cross things. Okay, so looking at the perpendicular height there as well, so that would be H2. Okay, and let us see then if we were to take the area of ADE, okay, and then take the area of AED. Okay, and let's see what we can do with that. All right, so yeah, question 9 there, it's fine, it can be covered. Yeah, okay, so in triangle ADE, okay, all right, the area there, okay, area of that triangle, it is going to be half the base being AD times the perpendicular height, which is H1. 1. Okay, and also if I look at triangle AED, all right, so the area for AED, it'll be half the base AE, the height H2. Okay, so I have a portion of the AD part, I have a portion of the AE part. Now DB. Okay, so if I look at a triangle, so now I have DB. Ooh, okay. My triangle DBE. Okay, if I look at triangle DBE, I'm still going to use the perpendicular height H1 because I can't use DE as a perpendicular height. It is not going to work. Okay, so let me just remove all those mini marks. So here I will have triangle DBE. Okay, and its perpendicular height will be H1. Okay, so in triangle DBE, okay, the area is half the base DB. The height there is going to be H1. And again, if I look at the other triangle on the other side, triangle ECD. Okay, so triangle ECD, the area there will be half base EC, height will be H2. The perpendicular height will be H2. Okay, so we have settled the DB part and the EC part. So now let us put all those triangles in ratios. Okay, the areas rather. So for area of triangle ADE, if I divide it by the area of triangle DBE, I get then half AD H1 over half DB H1. And do you see if we cancel the like terms, we're actually left with AD over DB. Okay, and then otherwise, if I also take the area of triangle AED and I put it over the area of triangle ECD, I actually get half AE times the perpendicular height H2 all over half EC over the perpendicular height H2. And also there, half and half cancels, H2 cancels, we are left with AE over EC. Okay, great. So now we have these two. But how do we prove, actually, that these two ratios, AD over DB, is actually equal to AE over EC? Okay, so here's one thing. Remember that if you have two parallel lines, the height there is actually the same. Okay, so we know that DE is parallel to BC, right? So the lines, they have an equal height. So that's both H and that's both H. So if I were to take triangle BDE, the area rather, if I were to take the area of triangle BDE, Would that work? Yeah, if I were to take the area of triangle BDE or DBE, okay, that is actually, because my base, remember, it's half, the area of a triangle is half base times height. So I will have half, the base is DE, and the height is H, okay, because it's a perpendicular height. Okay, if I also have a look at triangle ECD, do you realize that ECD is also going to have the same area? Triangle ECD, it also has the same area. I would have half base, which is DE, times height, which is H. Okay, so therefore I can conclude that triangle DBE, okay, let's use a different color. So I can prove that triangle DBE is actually equal to triangle ECD. Okay, so therefore DB can be equal to EC. All right, and then on top here, triangle ADE is actually triangle AED. Oh, what did I start with? Yeah, triangle ADE is actually triangle AED. So of course these two are the same thing. So can you see that I can equate AD to AE, and I can also equate DB to EC. So finally, as they want us to prove, yeah, so here we can say area, they're actually equal, we calculated, and we also know that triangle, so let's say the area of triangle ADE is actually equal to the area of triangle AED. Why? Because they're the same. Okay, so therefore I can conclude that AD, okay, over DB is actually equal to AE over EC. Okay, I hope that makes sense. I think maybe a simpler way of writing it out, I could have just written triangle, area of triangle ADE over area of triangle DBE is, well, I couldn't have said that they're equal at that point in time. It is through this that I showed that they're actually equal. Only then can I put the equal signs, if I show that the two triangles are indeed equal. So yeah, I hope it makes sense. That is how they would normally write it in the textbooks, but I hope through listening to this, you knew why, or you know why. Okay. So now let us go to the second part of the question. Okay, so bearing in mind all that we have done using the proportionality theorem, we are probably going to use it somewhere. Okay, so now it says in the diagram, M is the center of a circle. Okay, A, B, and C are points on a circle such that AC is equal to BC. Okay, so as soon as I have that information, I just want to, okay, so I have the length AC is equal to the length BC, meaning A1 is actually equal to B. Okay, PA is a tangent. So there is PA. I'm going to extend it. So it is a tangent to the circle at A. And when I hear that it's actually a tangent, I am reminded of the tan chord theorem. So I'm going to see, where do I have a triangle? So I have a triangle here, ABC. So I know that A2 is actually equal to B. All right, is that it? Yeah, that's all I have. All right, PQ is drawn parallel to CA. Okay, PQ, where is PQ? There it is. Okay, is drawn parallel to CA. So these are two parallel lines, and because there are two parallel lines, I am going to indicate that as well in the drawing. So I have my Z here. Okay, so I know that A2 is equal to P. Okay, and also if they are parallel, I know that I have a corresponding angle. So I have Q, right? And I have, no. Wrong one. This is the right one. Ooh, now my drawing is busy. So I know that Q is equal to A1 because of the corresponding angles. What else do I know? Okay, PQ is drawn parallel to CA to meet BA produced at Q. BC produced meets PQ at R, and AR is drawn. Okay, let Q equal to X. Alrighty, now determine giving reasons 4 other angles equal to X. Okay, this is where we should be flowing, right? Okay, 9.2.1. Okay, first of all, Q, I'm going to start where X is. Q is equal to A1. Okay? Q is equal to A1. Why? They are corresponding angles. And what is parallel? We have PQ parallel to CA. Okay, therefore, A1 is equal to X. And then we know that A1 is equal to, okay, what did I do? Yes, so A1, so that's the first one. Then we know that A1, I think I drew something incorrect here, but anyway, A1 is equal to B, okay? So we have isosceles triangle, okay? So that triangle is actually ABC. ABC, yeah, so therefore angle A is equal to angle B because AC was equal to CB. Okay, so now B becomes X. Okay, there's the second one. Then we have the tan-chord theorem. Okay, so we know that A2 is actually equal to B. Okay, because of the tan-chord theorem. Okay, and since B is X, A2 will also be X. So we have number 3 here. And then lastly, A2 is equal to P. Okay, or I should say P is equal to A2. Why? Alternating angles. Alternating angles where PQ is parallel to CA. Okay, we see that they A2 equal to P. So P is equal to X. And there we go, guys. 6 marks. We are done. We have 4 of them, so that's great. Now prove that ABPR is a cyclic quad. So where is ABPR? Okay, let us use another color. What haven't I used? Okay, let us go with black. Okay, so we have ABPR. So there's A, maybe let me just use circles. There's P, there is P, did I say P? ABPR. Okay, guys, sometimes this question confuses people. Like, how can ABPR be a cyclic quad? Basically, what they're saying is there is a circle, guys. There is a circle where ABPR is a cyclic quad too. Okay, so if there was a circle and ABPR was a cyclic quad, prove it. That's what they say. And there are 3 ways of proving whether something is a cyclic quad. Okay, first of all, I just like sketching. So if you have angles subtended from the same chord, okay, you can prove that it's a cyclic quad. Secondly, if you have an external angle that is equal to the interior opposite angles, that's one of the ways you can prove it's a cyclic quad. The last way you can prove that it's a cyclic quad is if you have opposite angles and you know that they are supplementary. So basically, if I add those 2 angles, I should get 180. So you don't have to prove all 3, just 1 is enough. And you can see it's 2 marks, right? So what can we do here? What can we use? We have our cyclic quad here. I just wanna, okay. I don't think this would work because I really don't have the sizes of the angles. The exterior angle, can I get that? Or can I use this? I think I'm more inclined to go with the first one, but I need to prove which 2 angles are actually subtended by the same chord. Okay, so let's see. If I use chord AR gives me B, and chord AR gives me P. Okay, so yeah, I chose the first one correctly. So basically, if I'm choosing chord AR, if this was chord AR, then I have B on this side, and then I have P on that side. Okay, and we have already proven that P and B are equal to each other. They're actually equal to X. Okay, so we can then remove all of this. Okay, so definitely we could say that because, actually we don't write, because we write it like this. Okay, so because angle B is equal to angle P, which is equal to X, ABPR is a cyclic quad. And the reason is angles subtended by same chord, and that chord was AR. Okay, a nice 2 marks. Alrighty, and then the last question for question 9. Okay, 9.2.3. Prove that BA over BQ is equal to BC over QR. Okay. Okay, I'm gonna have to draw. I've made so many marks. I'm gonna have to now see what's happening. Okay, so I am going to, okay, we have used, remember we proved that theorem there before, so I'm gonna use the lines that are parallel. Okay, the proportionality theorem. So I have B over there, all right, then I have A, C, Q, and R. Okay, the 2 parallel lines are, yeah, QR and QC. Okay, so if I then say BA over BQ, that's actually equal to BC over BR. Okay, and that is due to the proportionality theorem. Okay, so I can see we have BA, we have BQ, we have BC, but now QR. Okay, so how can we then show that BR is equal to, so here's BR. How can we show that BR is actually equal to QR? Well, if you draw it out, okay, we have Q there, and we have B, and we have P. Q was X, that was given, right? And then B, we solved it, that it was X. We proved it actually in 9.2.1, that B is actually equal to X. So if the two angles are the same, it means the two sides have the same length. So therefore, I would have, okay, but how do we get QR? Wait, sorry, it's not P. It's not P, guys, it's R. Oh my word, it is this angle. So let me just try use a different color. Yellow, I hope it'll be visible. So I have Q there, I have R, okay, I have B. So that is my triangle, and we know that Q is equal to B, not P. Oh, my bad. So yes, it's actually R. So I know that QR is actually equal to BR. Why? Because I have an isosceles triangle, okay, where I know that Q is equal, the angle Q is equal to the angle B, and I've already proved it before, so I don't need to write the reason again. So finally then I can say that BA over BQ is equal to BC, and instead of BR I can say QR. And that is it. We have proved it, and we are done with question 9. We are, ne? Yes, out of 17, we're done. Thank you for tuning in. If you have any questions, comments, please do comment below. Suggestions, anything, please do comment below. And I hope you've learned something. Hello everyone, and welcome to MV Tutors. This is me again, Solo, and we are looking at the last question of the supplementary exam written in June this year. Okay, question 10. What does it say? In the diagram, TSR, okay, let me just have my pen ready so that I can make notes as soon as they say something of worth. Okay, so in the diagram, gosh. Oh my goodness. This thing is failing me. I can't actually move it lower. Okay, let's try again. It is such a hassle to comment using PDFs. They take a while, and yeah. Anyway, in the diagram, TSR is the diameter of the largest circle having center S. Okay, so TSR is the diameter, and because TR is a chord, I know that Q1 and Q2 are 90 degrees. Okay. Yeah, so we have center S, and also chord TQ. So I see Q, where's T? Okay, there's T. Chord TQ of the larger circle cuts the smaller circle at M. Okay, so it cuts it there at M. All right. PQ is a common tangent. Okay, so we have PQ. Whenever I have a tangent, I try to extend it. Okay, and when I extend it, I have a look. Which triangles am I dealing with? But we'll get there. All right, PQ is a common tangent to the two circles at Q, and then SQ is drawn. Okay, RP is perpendicular to PQ. Okay, so we have a right angle triangle there. Okay, and then MS is parallel to QR. So MS is parallel to QR. Okay, so it means if Q here is 90 degrees, then M1 should also be 90 degrees. And also M2 will be 90 degrees, angles on a straight line. Okay, so what are they wanting from us? Oh, I actually wanted to highlight this. If I have a tangent, what comes to mind is the tan chord theorem. So I will see, for the small circle, I have this, right? So the angle Q3, Q3 and Q2. Q3 plus Q2 is equal, which one is the opposite? Is equal to M2. Okay, and then I also have a look at the other triangle. Okay, the other big triangle, so it is TQR. Okay, so the angle Q3 is actually equal to the opposite here, which is T. Okay, yeah, that's what I wanted to put there. I don't even know if we're gonna need it, but that's what I would do. All right, now 10.1 says, prove, giving reasons, that SQ is the diameter of the small circle. Oh, okay, so the fact that M2 is 90 degrees then says that SQ is the diameter. So first of all, what I would do, how many marks? It's 3 marks. How did I get to the conclusion that M1 is 90 degrees, which is equal to M2? I would say M1 is equal to, okay, no, it actually goes back. Okay, first of all, how did I know that Q1 and Q2 is equal to 90? Well, I would say that Q1 plus Q2 is equal to 90 degrees, angle subtended by the diameter, TR. Okay, they told us diameter TR. So I know that Q1 and Q2 are equal to 90 degrees. Then I know that, okay, let's just say Q then is equal to 90 degrees. Then I know that Q is equal to M1, okay, because that is corresponding angles where MS is parallel to QR. Okay, and then finally I know that M2 okay, I know that M2 is equal to M1, which is equal to 90 degrees. So basically I would say that angles on a straight line are equal to 180. So just angles on a straight line. Or you can just put it there, sum of angles, or just say angles in a straight line, but the sum of angles in a straight line are equal to 180. Okay, so now we know that M2 is 90 degrees. That's what I'm trying to get to. Okay, M2 is equal to 90 degrees. Now we know that chord SQ, so chord SQ is actually a diameter because it subtends the angle M2, which is equal to 90 degrees. It looks like a lot for 3 marks, but it is what it is. If you can do it in a shorter way, that's great. Okay, so that's 10.1.1. And now we go to 10.1.2. Now, prove giving reasons that RT, okay, so we have RT is equal to RQ squared over RP. Okay, how are we going to do that? Well, I know that I have two triangles that are right angle triangles. So I'm going to see if we can prove that the two angles are similar. Remember, there's a difference between similarity and congruency. Congruency is when they're identical, but similarity is when they are in proportion to one another. So if I can prove that the two right angle triangles are similar, then I think we can prove this RT shenanigan. Okay, so we have the big one. Okay, so we have T, we have Q, we have R. Okay, M, S. I don't really think we need to put that in. Actually, let me just ignore that part. Let's just write what we need. T, Q, R. And I see here, in the question I have RT. So here we have RT and QR as well. So that is a good sign. Okay, we have that triangle. And then if I also orientate QPR, so QPR is like a smaller version of TQR. So Q is there, P, that's where the 90 degrees is, and then R. Okay. So yeah, in the bigger triangle, that is actually R1. In the smaller triangle, that is actually R2. Okay, so what do I need to do? I need to prove that T is equal to Q. Okay, the angles. I need to show that Q is equal to P. Well, we already know, we've shown that Q is actually 90 degrees and P is given, it's 90 degrees. They told us that they are, QP and Q are tangents. So yeah, I think let's just start with what we know. So Q is equal to P. Okay, solved. We already solved in previous questions, so that's fine. We don't need to solve again. We don't need to show again. But now, equal to 90 degrees. T and Q. How am I going to show that T is equal to Q? Oh yes, the 10-chord theorem. Okay, yay. At least it's going to go by fast. So angle T is equal to angle Q, angle Q3. So Q3 is actually part of triangle QPR. So yes, T is equal to Q3, and that is due to the 10-chord theorem. Okay, so actually, yeah, I should have said Q, that one we solved. P, that one was given, because QP is perpendicular to PR. Yeah, I mean, this is 6 marks. You wanna make sure you're putting in things there. All right. Now, now we need to show that R1 is equal to R2. Okay, by virtue of Q being equal to P and T being equal to Q, then I can see that R1 will be equal to R2 because of the sum of angles in a triangle. Okay, so now therefore we can conclude that triangle QTR, should I even put it like that? Maybe I should say RTQ. Yeah, or RQT. So I would say triangle RTQ or RQT. Let's say RTQ. Triangle RTQ is similar to triangle Okay, then therefore we can say that RT, okay, over RQ is equal to, do we have a TQ? No, but we have a RQ, is equal to RQ over RP. Okay, so you have to take the corresponding angles. If I'm going to take the first two here, I need to take the first two that side. If I'm going to take the first and the third, it also has to correspond, the first and the third. So how you write triangle, blah, 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 is similar to triangle, blah, blah, blah. It is important how you put in those variables, okay? So now, yeah, it's working out, guys. So if we simplify that, RT is actually equal to RQ squared all over RP. And we are done proving. We are almost there, guys. Okay, 10.2. Now they're saying if MS is 14 units. Okay, let's redraw it again. Okay, this is MS, which is parallel to QR, and there's T. So now they're saying if MS is 14 units, PQ is, I'm just going to put that in red, PQ is equal to 640, root 640. Calculate, giving reasons, the length of the radius of the largest circle. So we are looking for TR. Okay, so what are we going to do? This is the last question. We have been on a roll. We shouldn't get stuck. What are we going to do? So we have MS is 14 units and PQ. Do we have anything in terms of PQ up there? No, we have RQ. Okay, so if I were to use, okay, so these are, what, 90 degrees? I don't know if that will help. Where is PQ? Oh, there it is. So I have PQ here. Okay, so we said that PQ is actually in proportion to TQ, right? Yes. Okay. And then MS. What can I do with MS? Okay. Let's come back here. So TQ, there's TQ. Okay, let me use my red. I'm looking for TQ. And I know that it is in proportion with QP, which is what they gave me. So if I were to say TQ over QP is equal to, how can I relate MS? Okay, I think there's a rule, guys. Ne? Did they say anything about TM equal to QR, MQ? Nothing. Okay, no. Oh, okay, all right. Remember that TR is a diameter. Okay, so if it's a diameter, it means that TS is equal to SR, which is also equal to SQ. Doesn't matter, we don't need it. But all of these, guys, these are radii. Okay, but my interest here is SR. So if I know that TS, this length is actually equal to that length, okay? And I also, there's a rule, I forgot the name, but if if you have triangles in proportion and these two are equal, the two lengths, TS and SR, are equal, then it means MS is actually half of QR, meaning that QR is twice MS. I don't know if you're going to need it, but hey, let's just put everything we know. And we know that MS is 14, right? So 2 times 14, that becomes 28 units. So I have the length of QR. Okay. I also have, what length do I have? I know that TQ is in proportion to QP. Okay. So I'm going to say RT over TQ. I don't know where that's going to lead me, but let's see. If I say RT over TQ is going to be equal to RQ over QP. RQ over QP. Okay. So what do we know? We don't know RT's length. Yeah, we don't know RT's length. We know PQ. PQ is actually equal to 640. Okay, and then what? I am looking for RT. So I know that RT is equal to TQ times RQ. Okay. And I also know that RT is RQ squared over RP. Okay. Oh yeah, yes. Okay. Now I see what I'm doing. Okay. Now RQ, which is the same as QR, is actually 28 units. We solved that and that's squared. And then RP, yeah, so I actually didn't need this. I didn't. I could have just used what I had before, which is what we solved in the previous question. So I know RQ is 28. So we're squaring it, and an RP. No, I still need that thing. Sorry, I thought I have PQ. No, I don't. Okay, so I still need to work. But yeah, I think we can equate RP to QP in this case, can't we? Where's RP? Okay, so this is RP, and where is QP? QP is that one. Oh, guys, I thought we were done. We are not. So how do I relate this? So I have RQ squared. RQ squared over RP. How can I make PQ relatable to RP? I don't have TQ. I've already used up MS. Okay, let me think about it. Okay, I think let us try Pythagoras and see where it'll take us when we're looking at triangle QRP. QRP. Okay, I know that QR, I've determined that it's 28, right? And then I know that PQ is 640. So using Pythagoras, I can actually get RP, which is what I'm looking for here. That's it, that's what I'm looking for. Okay, and then we can eventually get RT. So let's see if this works. So RP squared is equal to QR squared minus QP squared. So QR squared, that's 28 squared, minus QP squared, which is 640 squared, which is just the same as saying 28 squared minus 640. Okay, let us calculate it quickly there. Okay, my calculator is still thinking. So 28 squared minus 640. Okay, so the answer is 144. Okay, 144. And remember, we have RP squared. So RP is just going to be the root of 144, which is actually equal to 12. Okay, so I have RP. Great, we have RP, it is 12. Okay, guys, so now we can get RT. Okay, yes, like I said, we can actually ignore this. Yeah, so RT is 28 squared over 12. So what is 28 squared over 12? 28 squared over 12 is 65,33 units. Okay, is that it? So if MS is 14, we know that QR is then, okay, what's happening now? Yeah, MS was 14, so QR was 28. Okay, and then we're trying to get TR or RT. We already had an equation for that. We solved for RP and we found that RP is 12. Okay, so yeah, it makes sense. I mean, if this is 14 and that is 28, it kind of makes sense that it's 65,33 units. Yeah, and that is where the paper ends. Thank you for sticking with me until the end. I hope you learned something. If you need tutorial sessions, please do visit our website on www.nvtutors.co.za. You can make a booking. You can also, again, make a booking for a free consultation as well. And yeah, we'll be happy to assist you. Otherwise, you can WhatsApp 076 312 1107. All right, enjoy the rest of your day or evening. Yeah. All right, hello guys. So I realized I actually didn't answer the last question. It says the radius of the larger circle. Okay, so RT. Okay, RT is actually the diameter. So therefore the radius of the large circle is equal to 65,33 all over 2. Okay, and that would be 32,67. 32,67 units. And yeah, this is goodbye for real.